What up, chat? Good morning. Good morning. Shixie, how's it going? This drunk Dane, what's up, dude? How's it going as well? Ooh, my hair's sticking up a little bit back there. This drunk Dane, what's up, dude? How's it going, buddy? It's not gonna go down. Whatever. There we go. Abbott, what's going on, man? Abbott, you know what's funny about your name? There's a really good TV show I like called Abbott Elementary. You should watch it if you haven't. What is up, OET? How's it going, buddy? This intro slaps. Thank you, dude. My body is ready. My body is ready. What's up, Z? How's it going with the Cat Jam? Good morning. How's everybody doing today? Happy Wednesday. How are we? Damios, how's it going? Hello, hello. Wetsy, how's it going? Digital. Or Digit. Sorry, not digital. Digit. Digit Militia. Hello, hello. Remember, chat, I'm a bit of... Anybody else see a cat just like fly onto screen right there? I wasn't ready for that. Buddy, you need to calm down. Okay? You're at a 10 right now. Let's bring it down to like a 4. 4 is okay. 4 is okay. Yeah, he's in a bit of a... So, okay, so Edward might be a little bit feral. Oh, there he goes. What? Whoa. I'm kidding. I like doing this to him sometimes. Oh, he almost got it. He's just like ah! He's such a good boy. So he's not really a feral cat, but like he's very like he's just a very excited cat. He's got tons of energy. Check your focus. Oh, I gotta lean into the right area. There we go. Thanks, Cowface, dude. Thank you for the follow. Have we unlocked the cat? Looks like a game character to be unlocked. Yeah. What's up, Mr. Kappa? How's it going? It's like one of those, it's like a pet. It's like a pet in a game. Like, wow. No, he's a sweet boy. He's not actually feral, but he just like, he gets on these moods, man. And he just like, just like crazy, and we're all just like, oh my gosh, dude, okay, we're just gonna sit here and wait for this to finish. And then like he's pooped for like 2 days. He just has a lot of energy, and I think today's one of his I have a lot of energy days. That's all. Greebles. Edvin, how's it going? Hello, hello. But yeah, he gets excited. He gets excited. All right, so let's talk about today. Today's a good day, dude. I'm pumped. Okay. So for all of you here, for all of you early joiners, I have a special surprise for you. And I mean, the rest of the stream is going to find out too, but obviously you get to find out because you're here early. We are really enjoying your Rust streams nowadays. Great side listen while working. Well, I hope these ones are good too, because like, yeah, pause, because there's a lot of really fun stuff that we're gonna be doing. Hang on a second. My work laptop was sitting on a table, and he was right next to it. And I was like, let's maybe not knock over the expensive work laptop. So we're still going to be doing the Rust streams, Cowface dude. I appreciate that. To give you an update on that, actually, before I go into what I was about to talk about, hang on. Okay. Oh, I'm not in normal mode. Here, sorry. Let me show desktop. My bad. What's up, guys? Let's go into desktop mode. Cool. All right. So check it out, chat. Check it out. I'm pretty much at a good spot with build configs. So I actually broke Quirk over the weekend. Not purposefully, but not thinkingly, I guess it was a good way of putting it. And so I had to redeploy all of Quirk to Kubernetes again, basically. What happened was we were messing. So here, let me show you a couple things. All right, before we get excited here, too excited here. Can you hear him? He's meowing real loud. Okay, so there's a few things that I did over this weekend, and we'll talk about it. This is why I've not like been here in the past couple days. Well, and work's been crazy. So one thing I'm doing as an organization at our company, Alta 4 LLC, is I'm starting to break down the layers of our stack and basically how much they cost us. This is something we have not done before. This is something we do at HIP. Like, this is something we definitely do at Hippo. Don't get me wrong. Like, every part of the stack in Hippo is very well accounted for, thankfully. And Ellie does a great job of doing that. But at Alta 4 LLC, we have not had any kind of collective knowledge around it, much of that. And I'm sure, like, if you guys are running side projects or, even at companies potentially that might not have this kind of organization, this might be helpful to you as well. The TLDR is we have, as I've told you guys many times, a series of repositories that focus on the automation infrastructure within Alta 4 LLC, right? And so these repositories are like our DNS. So all of our DNS is set up in this repository. All of our machine users are basically like the things that we give other applications to connect to, like cloud providers and stuff like that. Like that's all automated. Our repositories, our buckets, what else? Kubernetes clusters, right? Like all of these things are in some way, shape, or form automated, right? And so in the sense of like the first one I'm showing you, Pulumi Network, if we go and we look at it, we can actually look at the infrastructure automation and say like, all right, well, what do we provision, And this will help us calculate. And again, this is an estimate, right? We're making an estimate here. We're calculating an estimate of like how much this could cost. And so we go to entry point and then we say like, all right, well, what do we got? Well, we got one base network here, right? One base network. And if we click on that, we can go to its actual structure and see what's inside of it, and you'll see that we get a new VPC, we get a new route table, we get a new internet gateway, we get some subnets, technically as many subnets as we defined in our config, right? We then get NAT gateways, at least one, right, in our public subnet, and then we get all of the routing connected and subnets set up so that the route tables are associated so that they can route to their specific NAT gateway and or internet gateway. And then there's a security group. So I took all of this automation and I sat down and I said like, all right, well, let's break it down, right? And I went to like their calculator thing. So I went to calculator.aws.com. If you guys don't know what this is, I highly recommend taking a look at it. And then I created an estimate and I said, all right, well, let's see what I can calculate, right? So VPCs, for example, I don't have a VPN connection, but I do have a NAT. I have at least one NAT, right? And we need to calculate some data transfer. Everything else is pretty much just like meh. I don't have to be super worried about it, right? But these two, NAT and data transfer, are going to be important. So we're going to have one NAT gateway. Bam, $32 a month. Not even like, oh, gotta love cloud costs, man. Not even put a single byte through that mamma jamma yet. And it's already $32 a month. Gotta love it. All right. So anyways, data process per NAT gateway. We want to be realistic. We probably would do about maybe maximum a terabyte right now. I'm going to be real. We're like over calculating here. This is purposeful. We should never process more than a terabyte of data at our NAT gateway a month. If we are, then we need to be aware of it. We need to have like alerting and stuff. So that's another thing to note about these costs, right? I'm not really saying like what we are currently actually, generating. I'm more so saying like these are the boundaries that I want us to exist in so that we can set accurate goals for cloud costs, right? This isn't necessarily like us falling back to a cloud cost. This is much more of like us making a target goal for a cloud cost because we are a smaller company, right? I don't have millions of dollars yet. Well, we'll see. But you get my point. And so, yeah, this is a goal. So we got one NAT gateway. Yo, what's up, Robert Tables? NAT gateways are the devil. Yes. Yeah, they really make it expensive to host private networks, man. It's pretty crazy for being a virtual private cloud company that they, would make it so costly to make things virtually private. Mind-blowing. NAT instances. Yeah, NAT instances are like a different approach, though. I'm not worrying about that right now. It would be interesting to know if setting up a VM to act as a NAT gateway, if it would cost less. It would. You would still get charged. Like, listen, no matter what, you're going to get charged for bandwidth. So these costs are going to move from the NAT gateway to your internet gateway. That's it. Right? Because if you think about it, your NAT gateway routes out through your internet gateway. Right? So most of that cost should just basically get shifted to that, essentially. The only difference is that it's public. It's going out a public IP versus a private one. There's a traffic processing cost on the NAT gateway. But the self-hosted one, I could create a VM right now. Like, I can create routes that they don't need to care about. You know what I'm saying? Well, that's what I just said. I just said it would either go from the NAT gateway or you'd start getting charged on the internet gateway. Where are you? Where's your mind? No, I'm kidding. It's okay. I'm still waking up too, Thug Muffin. But yeah, that's basically it. In any kind of like any kind of routing scenario, whether it be a NAT gateway or an internet gateway, if you go through a NAT, your NAT's just pointing to your internet gateway. That's what it goes through, right? And so even if I created a virtual machine myself and was like, hey, I want to have my own NAT thingy, whatever, service, whatever, right? I could create a VM in my network without Amazon having to know diddly squat. And then it just moves to, you know what I mean? Like, we're just processing, because when you create a NAT gateway, you give it a separate IP address. Trust me, I literally just did all this weekend. And so, yeah, that's why it routes out its own, and you have a separation of cost there. And I'm just messing with you, Thug Muffin, by the way. Don't take that personally. It's early and I'm tired. You're shifting the high availability responsibility to yourself with a NAT instance. Yeah, pretty much. Yeah, we'll bite the cost. Like, it is what it is right now. Soulburn, what's up, man? How's it going? All of these costs really support Akron's complaints about everyone other than Hetzner. What is this? Sorry. I feel like I know what you're talking about, but again, I'm also tired. And Jonah, what's up? Good morning. Oh, good morning. Ooh, hiccup. Okay. So anyways, again, we're going to have one NAT gateway. Now, here's the thing. Here's another thing. They actually do suggest you to have more than one NAT gateway. They're like, oh yeah, no, create two. And they say that because they want you to put one in each AZ, basically. If one AZ goes down, then your whole internet doesn't go down, essentially. So that's why they're like, hey, might be wise to put another NAT gateway in a different AZ. That's up to you. What I like to tell people about availability zones is that if a whole Amazon availability zone goes down, right, then an act of God has happened. Because an availability zone is like 3 data centers separated at least like a specific mileage apart from each other, normally at least. So yeah, that means like that's bad. So yeah, for us, we're just gonna have one. No, like internet gateway has no cost. NAT gateway has no cost of a NAT gateway. Traffic processing, outbound transfer. If you use NAT gateway, if you don't processing, just VM. Oh, you're saying that it's a simple cost of just data transfer. Yeah, I guess that's fair. Well, so this is their overhead cost of processing it through theirs. And what you're saying is that we would remove this cost, but we would still get this cost no matter what. I think is what you're saying. So you'd half the cost, not remove it completely. There you go. Is that? Yeah, I think actually, okay. I see what you're saying now. Yeah, I think that's right. Right. The processing cost. Okay, yeah. I got you. Right. At the end of the day, though, no matter what, the real metric is where it's going to be going through the data transfer, basically, of your VPC. Right. Okay, I see what you're saying now, Thug Muffin or Oh Thug Muffin. That's correct. Yep, I agree with you. Serious stuff is going down. Yeah, seriously. Not gonna be worried about your site slash business if that happens. Yeah, no. If an AZ goes down, it's or Amazon's just like, you know what I mean. Acorn. Oh, Acorn. Yeah. No. We know. Of course, we know Acorn. Yeah, has a spreadsheet with. Oh, that's right. I forgot about that. Yes. I've looked at that. That thing's really intensive too. I was like, holy crap. I need to open that thing up again. I remember looking at it and just being like, oh my god, I need to use this when I can think about it. It's like one of those like cards that you keep yourself for later. Like, okay, I'm gonna need this later. I'm just gonna put that right there. So in the end, you just have to pay them. Yeah, well, no matter what, right? Yeah. How about using IPv6 in the egress only gateway for IPv6? Right. Yeah. So you can do that. I don't like IPv6 Whisper. It's a personal preference. I just don't like dealing with it. I'm gonna be real. If they had like a virtualization layer where like it would change IPv4 to IPv6, there is a way of doing that. I don't know if you guys knew that, but you can actually translate IPv4 to IPv6. There's like an address space for it in IPv6. If there was like some kind of translation there, then that would be cool. And then maybe, like, I guess what I mean is like, if I just turn it on and still use IPv4 addresses underneath it all, then that'd be nice. But I don't think that's going to happen. So not yet. Yeah, I agree. IPv6 is great when everyone uses it, but when nobody uses it, it just sucks. I gotta start putting this over here so I'm not like doing product placement ads for Starbucks. Oh, hi Whisper. How you doing, by the way? Too much overhead. It's just a lot to deal with. Tulis, by the way, how you doing? Hertzner comes heads and shoulders above the rest. Interesting. Yeah, I remember looking at it. I gotta look at it again though. It's not terrible, but it does feel like a very big paradigm shift. Yeah, I agree. All right, so hey, listen. Let's focus. So again, basically what I did this weekend is I sat down and I broke down a lot of our cloud costs, right? We're just like going off on tangents here, you nerds. And so really what we're focusing on is that, now again, even if the NAT gateway is going to do like, realistically, this thing's probably going to do like maybe like 100, right? So it's like going to be $4 for us. That's why it's really not that big of a deal. I'm setting it to a terabyte to be like, all right, I don't know, maybe we like download a whole bunch of packages or I don't know, you know what I mean? Something like that. How do you get the Moonlander that tinted? Do ! Keyboard in chat. It's called the platform. It just came out. Well, no, it didn't just came out, but they're doing a new run of them, so you can order them now. That should work. Although I don't know. Yeah, that should work. Yeah, there you go. Whew, cool. All right. Like I said, I broke Quark over the weekend, so yeah. All right. So anyways, data transfer. So let's go and look directly at data transfer. Here's the nice thing, and I will say this, like, you can have a ton of data transfer and they're not going to charge you for it. That is nice. Now, realistically, we'll probably only transfer like a terabyte of data in. If that inter-region, we'll say a terabyte of inter-region, and then outbound. Again, now this would not happen more than likely. But yeah, if we were to, for some reason, transmit a terabyte of data a month, that is how much our networking, most of our networking costs is going to be around $191. And so if you look here, you'll see that that's exactly what we have, $191.57. Now, again, this is really like worst case scenario, right? This is saying that our NAT gateways process a terabyte of data, our inter-region has processed a terabyte of data, and our outbound transfer has also processed a terabyte of data, right? And so again, these costs on a massive company level, like on a big company, they're not much, right? Like, remember, for your website being your bottom line for most companies, this is pennies to making sure that it's solved, right? However, if you are talking about just like trying to break down the numbers, you do see that basically, yeah, it's almost $200 basically. $200 and you get a VPC with, basically enough room to play for quite a bit of, a bit of space. Again, I think a terabyte, like I think these are, like if you're just like an API based company, right? Say like you just like provide like a very simple front end with like APIs and stuff like that. This is probably well within your means of being able to scale to like, at least a 1,000 users maybe or something like this would get you somewhere, right? A terabyte of data. If you had a light footprint, on the internet with data, you could probably use a VPC like this and go pretty far with it. So again, $191 really isn't that bad, but it does provide us the whole networking layer, right? So I did this, I sat down, I calculated all this, and then I saved that, right? Now, we don't just have this, we also have the Kubernetes layer, right? And so this is something else that we have where we run Kubernetes for, a lot of our stuff. I don't know why it's not letting me move. Come on, what are you doing? What? Okay, I don't know what it's doing. But anyways, so we broke down the Kubernetes costs, right? And I don't really have to look at the thing here because I can kind of just show it to you. The EKS service, the managed service, right? So I should really put managed EKS service here, is $73 a month. Again, that's just flat. You enable the service, that's what you get. That's what you get cost as long as it's, running. This managed API service, or here, actually, let's get rid of it because I have managed here. This API service is, really Kubernetes APIs that are available so that you can attach EC2 instances to it, right? They control the control plane, and then you set up instances against that control plane. And so for us, we have 2 instances right now at the moment. We had 4. I scaled it down to 2 that run T3A larges. And so that's basically like $109 and 79 cents a month at the moment for us. Now, there's ways that we could bring this down. Obviously, like a lot of this could be tweaked. The total being $182.79 gives us 2 VMs. And again, that running in EKS. Another nice thing about running EKS, though, and the flexibility that we have here is now we technically could do like on-prem, right? So EKS has a service called EKS Anywhere. We could start hooking in server instances literally on our on-site and cut these costs a bit more if we wanted to as well, or like, put workloads in specific places. There's a lot of flexibility that EKS actually has. And again, if you're talking about being a company that wants to like scale, this is really a good setup to getting you to be able to do that. All you really have to do at this point is just scale EC2 instances. The last thing, I didn't do it, which is we also run ECS. These aren't the actual costs though, because these are the things from, what's it called? We still run this, but one of the nice things about ECS is you don't have that cost anymore. This is also, technically this is a repository, but we would call this ECS probably. Pulumi ECS. Yeah. Like that. This really just comes down to the cluster size of the instances. ECS doesn't really charge you much, so actually I can give you the cost right now. It'd be $109. Yeah, $109.79. One of the nice things about ECS is that you don't get charged for that control plane. You really just pay for the instances and the things that run on top of it, with some like additional like processing costs or something like that, I think. But realistically, yeah, ECS would be an additional $109. So our total right now in cloud costs, $191 plus $182. Let's get our calculator out because I can't do math very well. 191, what was it? 191.57 plus 182.79 plus. Now, I'm going to be fair. We actually don't. So right now, minus the ECS costs, we're at like 374.36 at maxed out, right? Which actually, when you really look at what you get, right? Again, you get something that's got a good amount of network space for you to be able to run things on top of. You get a Kubernetes cluster with at least 2 instances so you can start running containers on it. It's not too terrible. It's really not. And again, for a small company, $374 a month to make sure that you have like everything online and everything running, highly available and stuff like that. It's really not too bad. And again, this would also enable you to have a platform that you could then scale out, right? Because it's already on Amazon, it's already set up. You just start saying, all right, here's more instances. Now I am going to add ECS here, right? However, we don't technically have 2 instances here. We only have 1. So it would be like minus $54 or something like that. $54.50, I think. It's like $4.30, basically. So yeah, not too terrible, but this was something I did over the weekend. I sat down and I broke down all of our cloud costs. Because I did that, all right, you guys ready? And this is where the fun stuff really comes in. I was then able to say like, okay, now that I understand where we're getting where we're getting paid and or what we're paying for and everything, not getting paid. I wish we were. That'd be nice. You know, how do we want to organize everything? Kind of like actually start reimagining, you know, the whole infrastructure as an entirety. While doing this, Atoda, and this is where we get back to the story here of why I finished writing what's it called? Build configs. Sorry, super topic shift there. We went on a tangent. Was because while we were doing this, we were swapping out instances and things like that. And when I swapped out the instances, I basically accidentally made all the containers restart. However, all of the containers referenced an old registry in Azure that I had recently deleted on stream. And so those images weren't there anymore. So basically all of the Quirk containers started failing. Yeah, and so I had to basically finish writing build configs to be able to put my money where my mouth is and start generating configurations for basically 16 repositories. And so if we go to my development folder, right? And don't worry, we'll get back to the infrastructure thing in a second. It's relevant. You're going to see here that every single one of these repos, except for these, yeah, these every single repo I've got plussed here needed a new build done for it. No, it's fine. It's fine. It's actually totally cool because, as I said, you know, I wanted to put my money where my mouth was, and I wanted to make it so that, like, for me, you know, again, at Hippo, it's just something where I run a generate command, bim, bam, boom, and then I can have all the files and everything I needed. And that was the goal here as well. And so what I did was, for starters, I added support for, if we go to our config, I added support for Quirk, as well as recording pipeline and some other, and a project that we're managing for a company at the moment. And so, yeah, we added this Quirk product, right? And this product basically means like, what is the scope, right, of the thing that we're basically working on. And so after I did that, I also added a new template called service, right? And so service is a service template essentially, because basically everything that's being built is a Docker container, meaning that for us at least that's a service that runs in the cloud. I also added support for databases, so services can also have databases. And you might be like, BG, why did you do that? Well, because now if we go to build configs, actually here, let me just make sure I've got everything. Cool. And then we go to Docker file. Is it Docker file? Yeah. You can see that if we have a database, we install things now. And the same thing in Circle CI. If we have a database, I think. Sorry. Circle. Oh, I didn't make one for this. Oh, but anyways, yeah, basically once we make it, it'll have a database section in it too for migrations. And so we added that to the configuration. We also added the ability to do service post install. So one of the things that makes managing Docker files with build configs or this kind of approach possible or challenging is people want to add things to the Docker files a lot. and it's like they want to add it to certain places. But in a Docker file, there are places that can be really helpful that you can just kind of be like, all right, just whatever other commands you want, put here, right? And it's normally around like where you do your install and like your copy of your files and whatnot. And so right now we have two places that a user or a developer can inject, and a developer being me, of course, where I can inject additional commands. And so you'll see here like for command in dockerfile.post install after I've basically copied the files that I always want to copy, right? I then allow for other commands to be done and stuff like that. And then this is where we run the build command basically to make sure that we have everything that we needed, right? And we do the same thing here at the bottom where after we copy over the service level, and so this stage here is the service stage in the Docker file. Once we copy or once we finish building it, we do the same thing. Once we copy those files, we have a service post installed. So the service post install was new so that I could add other things to like the service container or the thing that actually is going to run in the cloud. Outside of that, I also added environments. So I made it so that a repository can deploy to like one environment or multiple. And so, for example, with like Pulumi, we only worry about running to or deploying to production because production is like all of our main infrastructure. Whereas, specific services might deploy to multiple environments and whatnot. And so like, a lot of this was pretty straightforward. A lot of this was me just defining the schema that I needed to and figuring out how to define that schema in Rust, right? Like we have a very simple enum here that sets up all the languages that we use: Go, Nix, Rust, and TypeScript, right? Again, all of our products, Alta4, Aya, Quirk, Recording Pipeline, right? Like all of these are the things that we build, that we make. So like, for example, if you're a company and you have products of your own, this would be your enum of products, right? This would be your enum of languages you work with. The templates, of course, being Pulumi and service. And eventually we'll have like front end as well, or, static or other things like that. And again, I really didn't want to add too much to the configuration just yet. I wanted to keep it super simple. So I was like, okay, I just need to know if a service needs databases. So if I know it needs databases, I can do things like, add migrations to the Circle CI file or like whatever. And so that's why it's just, but it's relative to services, right? I didn't want to make database something that was like just available at a higher level. Docker file, right? I showed you guys the build install or the build post install and the service post install. The other thing here is that I can actually override the registry. So I can easily just tell the build configuration, hey, I want you to build for this registry, and then it'll know like everywhere in all the templates how to build for that specific registry. And yeah, that's really it, right? We have a bunch of, now this is one of the things that I actually didn't mind as much with don't worry about that. Honestly, that's a project that we are like, that's an outsourced project that as Alta4 as a company has been contracted to work with. So it's not relevant to the stream at all. Yeah. It's something we're building for a company, basically. Yeah. But one of the things I will say that I didn't really mind is when you have defaults in Serde, it wants you to create like functions or, variables of some sort to be able to handle those, right? And so I actually don't mind this at all. This is kind of nice where it's like default environments, just return a vector, right? An empty one for now, but in the future, if we wanted to, I could say like prod is an array, right? And then this gets returned right here as default environments with the macro. Default Docker file, same thing. And then we get a lot of like high reusability where like default Docker file, leaked secrets. What? I didn't leak any secrets. Default Docker file just reuses the other defaults that we have here and stuff. So yeah, it's, like a lot of it's just boilerplate. Default product, obviously Alta4 LLC. So we say that if you don't define a product, then it's ours. And then the other last thing is that the template file. Now, I do want to figure out a better way of managing this. I think like what I'll probably end up doing is just making a simple like array of like data name path, right? Or like a or a vector, I guess, a vector of arrays of like data name paths so that I can just, iterate over this and create a bunch of it. But the main point is that then we have our Pulumi template, right? And if it is this template, then we basically render all of these template files, which I've created here. And so again, tsconfig.json, docker file, git ignore, pulumi.yaml. And as I want more, it's very simple, right? I just add another one. And so we did the same thing here with service, right? Template service, template file, docker file, npmrc, just file. And we'll add more to it later. We might even jump back into finishing that today, but we'll see. The reason why I wanted to show you all of that is because, as I said, I broke things without kind of realizing it. And so this saved me so much time, chat. I was able to come in here and very simply, like, look at this. Like, this is a Docker file that became a little bit more complex to manage than I thought it would. But because of the way I wrote the configuration, it's actually able to work exactly the way it was before. And so if we look at, like, again, how I'm using the configuration, you can see that the first thing I'm saying is this, all right, I want to override the Docker file, right? I want to say that after I do my post install, I want to copy GraphQL files, ESLint, jest, ORM config template. And then after we do the service post install, I want to just configure the or copy the template itself, right? And so now if I go to my Docker file here, look at this, right? Now I didn't write this in this file, right? It generated it for me. Build configs generated it for me because it knows about being able to iterate through that array in the configuration. So in this case, right, I didn't have to really write much code. I just told it, well, hey, this is the configuration I want it. Please, make it this for me. And so I got the Docker file that I needed exactly, which was nice. Backend API, right? That's the name, language, TypeScript, product, quirk. And then here's that database true, right? And the reason why we had that is because we said that in the Docker file, when we have database true, yarn add msub gets added here as well, which it did. Right? And so that's why we have this. Another reason why we have this is later on, when we have our Circle CI file added, we'll be able to run migrations in the pipeline and add that job or remove that job if we want to. So once all of these got updated, here, let's do this. Let's go here. 1 second. Okay. So once we did that, now if we go to container registry, right, we should see that Quirk has now got a bunch of repositories set up for it in Amazon, and it does. We were able to get all this created at okay, cool. All right, so let's zoom in a bit here so you guys can see this. There you go. So here's all of our Quirk registry, and again, as you can see, there's 17 of them here that I had to make in total, right? And so what did I do for each one of these? I went through, I configured it, I set it up, and I was like, okay, what am I missing, right? And if there was anything I was missing in the build configs schema or something I needed, again, whether it be like, okay, I need to be able to set the database and tell it that it has a database, or I needed the service post install, right? As I went through and trying to migrate the files to build configs, I basically started migrating the unique parts of a service to its build configuration. So this one, again, was a little bit more complex because, like, this is the API. Like, I'm sure a lot of you guys can probably relate to this as well. Your API normally has the most, like, heft to it. It's the thing that talks to your database. It's the thing that runs, like, migrations. Everything talks to it, right? Now with 100% more ECR. Yeah, exactly. Yeah, it's 100% powered by ECR now. But yeah, like, this is a more of a complex service, right? It's not just a simple service. So being able to support this in build configs was a good sign that was going to work for a lot of other things. So what did I do then? You ready for this, chat? After I set up backend API, and I told Atoda too, it was funny. I was like, dude, you know what? I'm not going to make these changes by hand. I'm gonna integrate it into build configs because I know Once it's integrated into build configs, I immediately get that next regenerate like instantly. I don't have to copy code anymore. It's automated. It's there, right? And so that's what I did. I basically copied this config. I came to backend Discord notification, and then I did the same thing. I created a build config for it. Now you'll notice this one's a lot simpler, right? This one's just like backend Discord notification, language TypeScript, quirk, service, right? And so when we regenerate this one, and then we go to the Docker file, you'll see there's no yargs anymore. There's no additional lines here, right? There's nothing else here either. And that's because our templating engine didn't want to inject any of those things. Now you might be like, well, BG, there's still like a bunch of additional lines there. That's fine. We just fix it in build configs and we regenerate all the things. It's not that big of a deal. I'm not worried about it. But it does give us the exact Docker build that we expected. The music just stopped. Hang on. Awkward. There we go. So yeah, like I said, if there's like bugs like that, we don't have to worry about it. We fix it once in build configs and then, you know, it goes away. And that was it. That was the first time. So the second time I used it, I immediately got exactly what I needed. And so it was like a really good sign of like, okay, this is awesome. So again, I might have spent like 20 minutes setting, 20, 30 minutes getting Quirk backend supported by build configs. But, and again, this is the power that I'm trying to share with you. And also chat, my front end master's course, I believe, is going to be coming out very soon. So be sure to keep that link available because I talk about this in that course. I talk about, reusability and seeing where you spend a lot of your time and saving that. Like that's what DevOps does. That's our focus. That's like what we are supposed to be doing is like, how do we save time? How do we save money? How do we improve things? How do we make things more efficient? Right. And so again, if we talk about this scenario where I've got 16 repositories that I need to update all their Docker files and everything I need to, having a CLI tool that can do that for me very quickly is super powerful. Right. And again, once I added support for backend API and I went to the next backend, right, which basically builds identically minus some things, and I generated based off of a configuration for it, I got exactly what I needed to. I didn't have to write anything. It was just generate, commit, push. Right. That's how powerful build configs can be when we're talking about saving you time. And so I did the next thing for backend LiftX. I said, all right, cool, let's do the next thing, build config. Now look here, this one actually had an ESLint RC and a jestconfig.js. So what does this mean? A couple things. It means that Jest and ESLint, as well as like some other things like GraphQL and stuff, aren't standardized yet within our organization, and they're not. I'm doing Jest testing in some places. I'm doing linting in some places. Like it's very, scattered in the sense of how we're doing that. Let me ask you something, chat, for anyone paying attention. What would be a way of solving that? How could what could I use, right? Maybe that I've been talking about that I could say, no, you know what? I'm going to make sure every repository has the ability of having a Jest configuration. If it's in TypeScript, if it's using linting, we make sure it uses ESLint, right? Like, what could I potentially use? Put it in build config. Exactly. No, literally, exactly. So this is another opportunity for you to be able to look at it and go like, okay, cool, right? We have ESLint in a lot of places, and I'm like having to add this manually. Well, forget this. Let's just take the ESLint file. Let's standardize it. Let's add it to build config, and then the next time we run it, now it'll be available everywhere. Will be where where build config exists as well, right? rm-rf ESLint, yeah, exactly, yeah, or that. Jestconfig.js as well too, right? Now it'll be up to the developer to make sure that ESLint.js and jestconfig are installed, right? That is something that we need to be aware of. Is like it will be like that's the package.json. To have standardizations around the package.json, that becomes a little bit more challenging. It's not to say you can't do it, but the best way I can put it to you is it has to be in build configs, right? Build configs. So you'd have to figure out a way of like injecting your packages, right, through the configuration into the package.json, and then like somehow it could be done, but it would be challenging. So we're basically build configs in a lot of ways only goes so far, right? We say if a pipeline fails, it's the developer's problem, right? And you might be like, well, that's kind of messed up, BG. Why would you? Because we have a supported configuration. Now, if the developer goes as far as they can to debug the problem and it's still not working, then of course, reach out to us. Like, we'll help, right? That's what we're there for. But when I say that, like, this should be something that should be standardized, it should be supported, and it should be, reproducible. We should be able to say, hey, this is supported, dude. Like, this is how it works. There's got to be something wrong with your pipeline. 9 times out of 10, you look at it, or your source code, 9 times out of 10, you look at it, it's a missing package. Something isn't there, something like that, so forth and so on. What about versioning? Well, again, that's what if you're talking about the package JSON, packages inject problem, I don't know the best way of solving that. We don't do that config versioning. We don't do that at Hippo. I mean, I guess like if you wanted to, right? Like you could say like, here, we're just going to mess with the configuration a bit here. You could say like packages, and what you probably would be best off is not doing it as an array, but doing it actually like as a dictionary structure, right? Of some sort. And then being like, I don't know, TypeScript, right? And then saying like, okay, I want TypeScript, and then like doing it here. Basically, this might be the best way. Now, here's actually what's really, really powerful about this that I like. And I'm going to be fair on this. I actually really do like this. Now that I think about this, here's why, chat. Because one, it lifts up the package.json to the developer, and it says, hey, you're in charge of configuring what packages you want. If you want a new package, you don't add it to the package.json, you add it to the configuration. And when you add it to the configuration, you got to version lock that mamma jamma. And it makes the developer think about the version they're using. I really like that. I know it's an extra step and it might be like slightly confusing. However, developers 9 times out of 10, I'm sorry, I love you guys, but you guys don't give a about versioning. At least when it comes to your NPM packages, you guys will just take it to the face, man, when it comes to packages. I have seen some NPM packages where I'm just like, oh God, right? And it's just YOLO install. It really is. It really is. Okay, hold on. Let me put up the table. The table, my desk, jeez. Cool. Yeah, and so like, I think this would be really powerful because this would make the developer have to. So to go back to how would you assure updating packages, OSC, it'd be on the developer, right? Hey, my TypeScript's out of version. Okay, go update it in your config. What I'm looking for is how this is going to let you quickly. Probably, woof woof dude, probably the quickest way to do it, in my personal opinion, would be to do like an NCU update and then just copy and paste. Seriously, right? Basically, yeah. Yeah, no, everything would be powered through the build config.json. Yeah. Again, this is just me speaking out loud, chat. Don't start taking me literally on this. I don't know how I would do this. I just started saying that you could do this with build configs if you wanted to, and that would make it so that you could also standardize. The goal here is not to talk about how we could do it. It's just to simply show you that if you wanted to standardize your package.json, right, that's what you would do. You would make it inherited to build configs, right? And so, yeah, same thing with ESLint and jest config, right? We add those to ESLint or JS config or jest, and then, they become standardized at that point as well. And if we look at our Docker file, right? Like, let's look at our Docker file here. Look at this. There they are. ESLint and jest config. So again, it's really reusable. Like it's the reusability here is really nice, and so what did I do right after I added those 4 lines of code, whatever, no, 2 lines of code basically, because it was just really this generated, bam, codes are done, out the door, right? Push it. All right, let's go to the next one, right? And we'll look at just one more. Look at that. Nothing. It didn't need anything. There was no additional configuration needed here. Generate, bam, bam, boom. So basically, why am I talking to you about this? Why am I talking to you about this? What does this have to do with the go live notification today? Like, what does any of it mean, BG? You've gone down many tangents. You've planted many seeds in my brain on things that we're working on. But what does it all mean, BG? Why? Oh, chat. So listen, there's this thing that we've been working on for quite some time now called Quirk. And I would say last year for sure, we took a break from working on it. We maintained it. We kept it alive, mainly because it is still what powers our stream. But we haven't really been trying to focus on getting it out the doors like a product and a lot of the things we've been wanting to try and do. Well, it's a new year, baby. All right. And BG's got a lot of things he's trying to do this year. Is the Tenting Kit worth it? In my opinion, yes, it is. And so when I started being, once we were able to like look at our cloud costs and look at like what our infrastructure currently is and kind of like think about like, okay, what would our future look like in Amazon or wherever, like, do we want to run containers? Do we run EKS? Do we want to run ECS? Do we like Kubernetes? Do we want both? Like, how would it work? What would it look like? And I sat down and I thought about it, and I was like, there's a really good opportunity here to start basically building from scratch. Now, Quirk is basically entirely containerized right now. It's written in TypeScript. It's using 2-year, 3-year-old libraries for pretty much everything. And it's also designed by a black glasses that did not know as much as he knows now, for sure. And looking at the platform, one of the things that I had to accept is that I'm just not very excited with building it the way that it currently exists anymore. What it does and its abilities that it has are very powerful. However, I could build the platform with way less management, way less cloud costs, and make it very scalable with, again, much more precision today than I could have, 2 years, 3 years ago or whatever when we started the project. And so that has been something that's been sitting in my mind a lot lately, at least for the past month and a half. But Quirk has been stuck because it's been running again on Azure, Azure images, and it still had a lot of connections to like what that was before. And we hadn't moved from that yet. And so I was like, all right, well, until we get there, I'm not going to worry about it. Well, when I broke everything this weekend and I had to basically make it standardize everything to build configs, that was really when it was like an empowering moment to be able to be like, oh man, like we just cleaned up 16 repositories. Like we can actually at least manage this stuff a little bit easier now. Like, does it make more sense to, to move forward on Quirk now that like it's in a manageable shape again? And the answer to that was yes. Like it made total sense. We finally got into a scenario where last year was also very challenging for us just because we had a lot of side projects and other things that we were doing to try and get like the company off its feet and things like that. And so again, we just didn't really have a lot of opportunity to be able to think about Quirk and give it some love. But now, especially again, with the ability to be able to focus on it, I really want to. Now, one of the things I want to do, I want to rewrite it from scratch. I want to we're throwing everything out the window. I really don't want to reuse anything. And I think that the biggest goal here is going to be two things. One, I want to build it in something that I can be very fast in, right? But I also want to build it in something that makes a lot of sense. And so I think I know what that is. But it is definitely something that, like I said, I want to make sure that I can build very quickly in it. That I can, keep iterating on it very quickly. and that it's something that I can very easily manage, because a big reason of why we're going to do this is so that we can release for a very special event that happens every year. We're going to try and target our beta release for TwitchCon this year's TwitchCon. So we basically have from now until September to completely rewrite Quirk, chat. That's the goal. That's the big goal. So we need to be aware of that. We need to be aware of what we're trying to do. We need to be aware of our time. We also need to be aware of our priorities, right? We're not going to just be building a platform from scratch here again. We're also going to be paying for it. We're also going to be putting users on the platform. You guys, we're going to wipe the whole user database basically and start from scratch, invite new people back on. Norlock, anybody who wants to use it, it will be completely open and available, right? So we want to really give Quirk the ability and the chance to try and flourish. About Quirk, I suggest to rename it to King. How old is Black Glasses? I am 34. I'll be 34 next month, but yeah, I'm a little bit older. Is the tenting kit worth it? In my opinion, yes, it is, Zeth. It is. How's it going, Zeth, by the way? Hi, Mart. How's it going? Hello. You done something to learn. Learn to understand that some decisions were not good as fit in those sense today. Time to move forward with that new knowledge. Exactly. Yeah. So go, Rust. Go. I like how you guys are all like, go, Rust. Go. Oh, no, you're fine. Not going to lie, this is inspiring for me to go and want a personal project again, but I need to leave him home in 10 minutes. Well, hey, as long as we can inspire, that's what we're here for. Why not create a side platform so it doesn't break people already are on there? So, woof, dude, you are... Woo! You know what? You've been here long enough to start thinking what I'm thinking. I love that. That is what we're going to do. Yeah, that is what we're going to do. So that's going to be one of the goals, is we're going to replace Quirk piece by piece, right? We have to be able to keep what exists now online, because that's another thing, right? We need to be able to keep what exists, but also move off of it selectively, right? And pick specific things that we're going to build this again. We're going to build this specifically piece by piece, and we're going to think about every part of Quirk that works and how it's going to work, right? And I actually know what we're going to be focusing on first today, and what we're going to be rebuilding from scratch today, or not from scratch, but we're going to be focusing on rebuilding from scratch. And it's also a massively important part of Quirk. It's one of the most important part of Quirks. As a matter of fact, if this doesn't work, people won't use Quirk, okay? So this is one of the most important features of Quirk that we're going to be rebuilding first, which is what I'm really excited for. I don't know if I say, is it Suet Mao, I think? I'm sorry if I can't say your name right, but hello. I'm sorry if I didn't say your name right. How are you? So yeah, what was I saying? I lost my train of thought. Let me re-chat, and that will help me remember. I was almost able to drive when you were born. It's okay. Listen, I understand age now enough to be able to just say, I appreciate it. And BG was probably driving by the time I was born, 24 here. Was I driving? No, I wasn't driving. I would have been 10. I would have been 10, Aramis. Not that old, but you know. I shouldn't say that old. I'm sorry. For anyone who's older than me, I'm sorry. I don't mean to be that guy. Go and Rust are nice. I'm doing good. I've also been designing a private framework for my work, and I can relate how much the struggle is to encompass all, especially without luxury of open sourcing. Yeah. No, it's, I mean, again, there might be things that we open source as well. Who knows? I don't know. I just realized my math is wrong there. Yeah, no, you're fine. You're fine. All right. So I want to ask you guys something first, and I really want to get an opinion here, which is, which do you think we should use? Now, the question I'm asking for is going to also lead to the answer that I think I know I want. So check it out, chat. As I've said, we want to rewrite Quirk from scratch. And to be fair, this also doesn't necessarily mean that it has to be just one of these things. Like we could do both. Like in all seriousness, there's a solid chance that we will do both, right? We can interop between these two. But I want to pose some questions to you. All right. I want you to put your engineering hats on for a second. I need you guys to take this seriously. I want you to take your Twitter hats off. I want you to take your YouTube hats off. I want you to take all of your other hats off. And I just want you to have your engineering hats on. Your Twitch hats, take off your Twitch hats. All hats, right? All hats, right? Just you know, engineering hats. So we have 6 months, basically, to build and rebuild a platform from the ground up. Now, this platform is a platform that's a real-time focused platform, right? So it's going to be handling things like messaging. It's going to be interfacing with APIs. It's going to be interfacing with cloud resources. And it's a web app, right? So it's something that also is going to be on the internet. It'll have a front end, right? With a you know, API of some sort to support that front end. Now, it doesn't mean that we have to necessarily build that entirely for an API for one thing, right? Like we can have a distributed microservice approach and try and, you know, really solve our problems the way that we want to. But I'm going to put 3 languages here because I think the other one is still a pretty valid opinion. But the TLDRs is that, again, the goal here needs to be, we need to be able to move quickly. We need to be able to support it very well. And we also want to limit like errors, right? Like we want to make sure that we aren't stepping over or tripping over ourselves a bunch, that when we write code, we write it once, it's concise, and then it, you know, solves the problem that we're trying to solve, right? So I'm going to give you guys the option of 3 different languages that you guys think we could potentially use to write these services in. Now, again, this doesn't mean we're going to use one of them. Doesn't mean we're going to use 2 of them. Doesn't mean we're going to use 3 of them. It's just simply, I want to know from your perspective, based off of the parameters that I just gave you, what you think you would pick. Okay? Cool. All right. Here's the poll. So which one would you use? Would you use Go? Would you use Rust? Or would you use TypeScript? And I put TypeScript in there purposely because it is still a very valid opinion and very valid option. Seems you want to mix between Go and Rust, to be honest with you. Yeah, I mean, possibly. But again, right now, it's not about what I want. It's about what you guys think. So Agile, basically the requirements are, we have 6 months to build it. We want something that has very strict to it. You know, we're not creating a bunch of like things that we're tripping over. We want to be able to move quickly. We want to be able to also manage it well, right? But it needs to be, it's a well-rounded, right? It's not something so much that we just want to go fast and deal with crap, right? It's like we need a middleware, a middle ground of like moving fast, having good tooling, but also being able to build to, you know, potentially a binary or something, like, you know what I mean? Like just thinking about the whole thing, right? Rust. Let me catch up with chat. Where's that keyboard from? It's called a Moonlander. There you go. Ruby on Rails. Andy, I mean, Ruby's not terrible, but question back to you. What would keep you excited for the next 6 to 8 months? Any of those languages? Well, probably not TypeScript. TypeScript would be the only one that I would just be like, because I've already built it in TypeScript. However, there's still, like, I could build the fastest in TypeScript for sure. Yeah. There's a poll. Yeah, there's a poll at the top. Yeah. But yeah, no, I mean, Go or Rust, honestly, would both be very interesting to me. Rust would hands down be the most challenging because I would just be tripping over myself probably quite a bit. But again, my opinion does not matter right now. I want your guys' opinion. I want what you guys think based off the parameters I gave you. If I walked into your office, as a PM or whatever, and I was like, all right, listen, we got 6 months to do this. We got to get this quick. Listen, I want you guys to feel like you can give me the best product you can. However, we need to be able to manage it. We need to be able to have other teams be able to manage it. We need to be able to have we need to be able to join as a team around this language and build the software that we want to build. Right. In my most services should be Golang, since I think you're good into it. Rust performance matters the most. Seems like you want to mix between Go and Rust. I mean, again, possibly. Maybe consider looking to WebAssembly as a target instead of containers. Yeah, absolutely. Trust me, that's something we're not looking at. So Go. So 59% of you said Go, with 22% of you saying Rust and 19% of you saying TypeScript. So hold on, before I go over those, let me just get through the rest of chat here. Fast, easy to develop, use Go. Rust is better if you need to create very large binaries. 6 months is really not a lot of time. Woof, it's not. Even though I love TypeScript, Go is a better language for that. Less code and has nicer error handling. Yeah, I don't disagree. For dev experiences and reduce risk of errors, Rust for good runtime and performance scalability. Go. Don't disagree. Let's see here. After a week in Go, I promise your Go code will write even faster than TypeScript. I wasn't too worried about the decision around TypeScript. I think you were thinking about this as an engineer, you would already have done it in Go. But you will come out of it victorious. Oh, you mean with Rust? I mean, again, I'm not against looking at Rust. We can evaluate it, you know what I mean? But we need to evaluate it in a way where we can look at it and be like, how logical is it to build the specific service that we need to? And so maybe that's something else we're going to, actually not maybe, that is something else we're going to do, which is every service we build, we're going to reevaluate the language we build it in. How about that? How about I make that promise to you, chat? Every time we build a new service, we will evaluate the languages that we build it in so that we can make the best decision for it. I like that idea. Go will be easier to write than TypeScript with less than a week of building it. Yeah, you know what's funny is it used to be the opposite. I feel like a lot of people would be like, yeah, no, it's super easier to write in TypeScript. Go is just so hard. And then it's now Go's become so common. Everyone's like, dude, you know what? TypeScript, dude. Have you used Go lately? I don't disagree, though. I really like Go. What languages are you comfortable with if speed is important? If speed is important, Go and TypeScript. Yeah. And Python. Yeah. Python, Go, and TypeScript, I can go fast. I go zoom. I go real fast. What about .NET? No. Don't do it in Python. I'm not going to do it in Python. That's why it wasn't even on the list, Seth. It's not even on the list, all right, man? I got to shoot myself in the foot that hard. Rust also has an advantage of more Twitch viewers, maybe. Hey man, listen, give over them numbers, you know what I'm saying? You know what I'm saying? I appreciate you, Agile. That was good. .NET is my day job. I'm sorry. I didn't mean to make you feel sad. I'm just kidding. It's so hard to find documentation about Go and libraries. That's because everything in Go libraries is in the main Go pages thing. It's just those pages, those documentation. The Go documentation generator sucks. All right, I'm gonna say it. I'm putting it out there. It sucks. It's hard to read. It's ugly. I wish they had better generated documentation for Go. I will say that. Okay. So chat, I have announced what we are doing. If you are just getting here, hello, I am BG. I'm one of the co-hosts of the Ultra 4 stream. If you are new here, be sure to check out that little blurb right there. The thing that told you that little blurb is actually what we're talking about. It's something called Quirk. And if you're curious about that, Quirk can help you out with that too. The TLDR is that we are going to be rewriting Quirk from scratch with the target goal of releasing our beta in for TwitchCon this year. We've been talking about it a lot, and over this past weekend, by basically breaking it entirely and then rebuilding all of the images in Amazon where it should be, we effectively migrated it without meaning to migrate it. And so now we have an opportunity where Quirk is actually in a place where it can be managed. Again, I showed you guys how we can manage it with build configs. And so, yeah, we're at a place where it's like, you know what? We can rewrite Quirk, right? Like this is something we really want to do. Quirk has also got pieces to it that are kind of limping. Things that like I want to be able to, I want to be able to have more reliability and consistency around that. Because of the way it's written, it would be like a rewrite in itself just to get it there. And so it just makes sense to start from scratch, right? You're going to rewrite Quirk in half the time I subscribed. Dude, I'm excited. Haplo, how's it going? Hello. And so, yeah, basically the idea is that we're gonna rewrite the platform. We're gonna do it bit by bit. And the goal here especially is we're gonna do this the DevOps way, chat. All right. We're gonna look at specific problems that Quirk solves. And we're going to try and solve each one of those problems the best that we can, right? We're not going to look at it from a circumstance of like, all right, well, how are we going to do this or how are we going to do that from a technical level, right? Containers, blah, blah, blah. But, okay, we need this feature and we need it to work really well. How are we going to get that to work really well? Okay. So let's go ahead and get started and we'll talk about what the first thing we're going to work on is. As a matter of fact, I guess what we'll do is we'll say, one second, chat. Okay. Let me figure out exactly how I want to solve this problem or how I want to write this. Okay, cool. Yeah, that's what we'll name it. All right. I had to figure out what I wanted to name the technical document so that it was easy for you guys to understand it. All right. So if you guys do not know what Quirk is a streaming tools platform, right? Quirk has been built over a long period of time to solve streamer problems. Hold on. As a matter of fact, this is Quirk. This is its old interface, its current interface, the one that, if you are on the platform, this is what you would see. And this is basically what we initially created as a way to kind of get started with using it. Now, to be fair, a lot of this is like very broken. I don't think many of these things work except for a couple of them. But the TLDRs is that we do solve specific problems with Quirk. We have a calendar service, which allows you to basically set up events in your calendar and then set up notifications for it. That goes over this concept of what we have connections, right? And these connections are basically everything that Quirk talks to, whether it be Discord, whether it be Twitter, right? Other things in the future, YouTube, so forth and so on. And so we have our calendar system. We also have our chatbot, right? Our chatbot is what powers all of our commands. So whenever you put in a command in Twitch or in Discord, right, this is all powered by this chatbot system. We have integrations as well, right? So those connections that I told you before, which really needs to be called integrations now because that's what we call it. We have integrations with like specific things, Discord, LiftX, Twitter, Twitch, right? So for example, Discord, we have Discord moderation for like human verification. So when a user joins a Discord, they click a button, they then have verified, they get a role, and then they can see the rest of the Discord. And that's actually something that we have in our Discord, where if you go to it, if you're joining, you'll see, look at this. We've got 2 people who've joined, but they've not human verified yet. And so because they've not human verified yet, they're just sitting basically in purgatory. Where, they don't see, and again, we say here, you will not see any channels until you verify below. And that's the case. Nobody can see them. They can't see anybody else. And the only reason why I can see the human verification channel is because I'm an admin. But yeah, they're completely locked off. And so this is a feature. This is a part of Quirk. We also have system messages. So Quirk will actually tell you when people join, when people leave, when people do human verifications, when they do message updates, deletes, stuff like that. Welcome messages. If you guys are in our Discord, if you're in Prime's Discord, you might notice that when somebody joins, you'll see like a message that pops up. Let's see. When was the last time somebody joined? I don't know. Oh, there you go. Yeah. So yeah, there you can see here. Welcome to the server. Burp. See? So yeah, that's a feature in Quirk. So again, you're starting to see all of the problems that Quirk solves, right? And these are all problems that we need, right? We have the role feature now too, which is like manage roles and stuff. We have OAuth processes so that we can actually connect and all of that stuff. You know what I mean? LiftX, so when you guys follow, when you guys subscribe, all that kind of stuff, we actually have these concept of stream alerts where it basically changes the lights, right, to these specific things. Twitch channel rewards, obviously when you guys do rewards and stuff like that, you have redemptions for changing the lights and stuff too. Notifications are go lives, right? Go offline as well. And then we have Twitter so that we can send out Twitter, and Twitter is very simple. It's just to connect. If you look at loyalty, we've got giveaways, which is just a basic giveaway system. Reputation as well, which is a system that's focused around basically points that are generated in your system. And then we have account stuff, which is just like setup. And then we have our developer API, which allows other developers to connect to our APIs and get like all of our messages and stuff like that, right? So Quirk does a lot of things. Quirk does a lot of things, even for what, you know, the small project it is. It's a chat bot. It's got integrations with other bot systems as well. It has integrations with other APIs that do things like can change your lights, that can send go live notifications for you. Again, we have a calendar system in here so that if you want to like keep your community up to date on things, you can have scheduled, notifications and stuff that go out for you. There's a lot of really cool things here. However, one of the big and most important things, so out of everything I just showed you, chat, what would you say as a streamer, what would you say is probably one of the most important features? Out of everything I just showed you, what do you guys think might be one of the most important features in Quirk for a streamer? I remember when you look into Temporal Sense, you're doing is a lot of the solve, but I don't know what your conclusions were on it and if it would make sense in a rewrite. Maybe. I don't know. We'll see. We're not there yet. Woof woof, but maybe. Events and chatbot. Okay. Integrations. Okay. So with regards to integrations, what specifically? So like, again, I think OETC's in like that more that specific, right? Like what integrations specifically? Like, again, chatbot stuff. Do you think it's calendar notifications? Like, what do you guys think? What are you planning for the front end if you use Go? Okay, I'm going to tell you guys all something that I'm going to say, a friend of mine and like / pseudo mentor tells me a lot. Don't think technical right now, right? I don't know what we're going to use for the front end, right? Who knows? I have no idea. It could be Rust and WASM. Who knows? I don't know. It could be TypeScript. I don't know. We're not there yet, right? What question I'm asking you is, what features do you think are most important to a streamer, right, in Quirk right now? What do you think are our biggest priority features? I mean, it's definitely integrations, but like, what integrations do you think? Like, what specific features do you think are important? Alerts. Okay. With Twitch specifically? Yep. API backend, nothing will work without it. Yeah. Okay, that's fair. Probably the best thing of centralizing things in one place, always helpful. Oh, yeah, I got you. Go live notifications. Alert, follow, sub, donation. Okay, yeah. I want Quirk to be able to grant revoke roles based on whether the user in question is it. That's something Quirk's going to be able to do. Don't worry. Yeah. So Wetsy literally just hit that mother right on the nail, man. Go live notifications. If a user does not know that you are live, they do not know to tune in. The go live notification for a Twitch streamer is the equivalent of being like, come on now, let's go, get on down the bar now, come on, like, ding, 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 like, that's us telling you guys, Let's go. Come on, get your butts in the seats. The show is starting. And if that doesn't work, if that does not work, then you could be live for an hour to 7 people and not know what the is going on. The go live notification is hands down the most important feature, if not one of the most important features, and probably will still be for a long time. That is one of the first things as a streamer you really care about. And again, going back to like alerts, integrations with Twitch, right? Like all that stuff, you guys are in this like same category, right? Like as a streamer, our biggest priorities in a lot of like earlier when you're first getting started as well is to figuring out how to making your stream feel more connected to you, right? And alerts, things like that, like where you can react and like it feels like an experience, is super powerful and super important. You know what I mean? Discord notifications save me from missing streams, not gonna lie. Exactly. Right. And that's another thing too. Like there's platforms like, as I'm sure some of you guys know, there are platforms out there that'll like change your Twitter handle for you and stuff like that. And like, don't get me wrong, we'll do those too. Like that's totally fine. We can do that stuff. I want to make sure that we do it the right way. I don't want to accidentally like make a whole bunch of accounts get stuck. That was funny. But yeah, no, like I want to explore every option that we do, you know, to its fullest advantage and be able to be like, okay, cool. Like how can we build this the best? So when we think about, well, yeah, right. When we think about go live notifications, right? Problem. We have no way to provide notifications to integrations that exist within Quirk. So that's going to be our problem, right? Rust Live notifications, am I right? So this is our problem, chat. We have no way to provide notifications to integrations that exist within Quirk. That's it. We're starting from scratch, all right? So I'm not going to lie. I have thought about this a bit. So I have a question to ask you. Here, I'm going to do another poll. We're going to do a poll really quickly, which is, which would you prefer? Break down the problem or jump to, we'll call it a pseudo solution or we'll call it a pseudo idea. All right. I'm going to give you 2 minutes. Would you rather me break down the problem or would you rather me show you what I'm thinking and then we can kind of work backwards? That's what I'm asking you right now. Break it down. Okay. Kip, thank you for the follow. I appreciate it. Actually, here, you guys poll really quickly. Let me go to the bathroom while you poll really quick, okay? Let me poll. Again, it's up to you guys. If you want me to, let me put it to you this way. It's going to get broken down either way. If we jump to the pseudo idea, you just get to see the tech first. Whereas if we break down the problem, we're going to get to the tech last, that's how you should do it. I just want to make sure that you know we're going to do it. Yeah. Yeah. All right. Let me go to the bathroom really quickly while you guys do that. Give me 1 second. Be right back. Hi. Which one won? Oh, I missed it. Which one won? Did I really miss it? I didn't even see which one won. Break it down. Okay. All right. Let's break it down. We're going to break it down, chat. Now, here's the thing. I've already broken it down, so I'm technically re-breaking it down for you. Now, the reason why it's actually good, for starters, I'm proud of you. Breaking it down is always the right way. For any of you who didn't want to break it down, that's fine. Again, sometimes it helps to be able to see the whole thing first for you to understand the problem, so it's all good. I totally get that. But when you're solving a problem, you should definitely start with breaking it down. So let's do that. Let's solve this problem by breaking it down, okay? And what we're gonna do is we're going to go to our old pal Lucid Charts. You ready, chat? You ready for BG to give you guys some wireframes? Let me open the other one on the side here because I'm basically just recreating a chart I've already created. Okay, how many of you here know what Twitch event sub is? Give me a 1 in chat if you know what Twitch event sub is. Anybody? Anybody here know what a Twitch event sub is? 1. Okay, I got 1. All right, 1 person knows what Twitch event sub is. All right, I'll break it down for you. For anyone who doesn't. So, Twitch is a streaming platform that you are currently on. No, I'm kidding. So the idea is that Twitch, has a lot of events that happen with it throughout a stream, right? When you guys send a message, that's a message event, right? When you follow, that's a follow event. When you subscribe, that's a subscribe event, right? Things like that. And so Twitch obviously collects these events and handles them with, messages within their dashboard or messages in chat, things like that. What Twitch has done, and this has been going on for a while now, is Twitch has also said, hey, we understand that you want to be able to integrate with us as well, developers, right? Developers. And so what we're going to do is we're going to provide you with APIs or endpoints or services as a way of being able to do that. Now, there's been a few iterations of these over the Twitch years, and I have been lucky enough to be able to experience the other two just terrible experiences. But the first two were actually a combination of webhooks and WebSockets. It was what was it? It was their old pub sub, right? And the pub sub was basically powered by WebSockets. And the idea is that you make a connection to them with WebSockets, and then you open up a bunch of different listens, and then they start sending you those events over the WebSocket, and you get those messages, and you handle them, so forth and so on. There was another one. I don't remember what it was called. It's deprecated now entirely. I officially now hate the Slack API. You need an enterprise account to delete some things, which makes... oh, dang. That sucks. I'm sorry, buddy. How's it going though, Johnny? Outside of that, by the way. And so, yeah, basically they had these old implementations of interacting with Twitch. And then about a year and a half ago, Twitch came out and was like, yo, we got this new hotness. It's called Event Sub. And guess what? Every event you want, that's where it's going to be. And the problem is back then, before Event Sub, some events existed in PubSub, some events existed in WebSockets. And so it was like this mishmash of like, okay, you'll get some here, you'll get some there. And Twitch knew that as a problem. And so they said, okay, well, we're going to fix that, and we're going to make a new thing that integrates those two things together so that we really want to just solve the problem of Event Sub or events, right? Now, as developers, really, this is what you want to work with when we're talking about integrating with Twitch, or at least from an events perspective. It has actually been very well thought out. I don't mean to say it rudely. I think Twitch is a great company, in the sense of their engineering is actually pretty good. And I do think that Event Sub was a enterprise approach to solving receiving events from Twitch. I really do think they did a good job with Event Sub. I think it's very well implemented. They follow RFCs very clearly, which is great. It's very easy to at least troubleshoot and understand and even scale. To give you an example, we have probably 100 and something webhooks registered with Event Sub right now. And we receive them at all times throughout the day. And being able to scale that out was really not that bad. But this is really where you're going to start, right? And so there's two different ways of connecting to Twitch. There's webhook and there's WebSocket, right? The TLDR is the webhook approach is your generic, hey, I need a webhook. Okay, I'm going to register you a webhook. Okay, cool. Now, whenever this event happens, I'm going to hit this endpoint that you told me to hit, right? And Twitch being the thing that's going to hit the endpoint, right? And so that's a webhook, right? Now, there's also the option of well, actually, before I go to the WebSocket option, webhooks, pros and cons, okay? Pros to webhooks. Actually, here, let's start writing this down now that we actually like know some things. All right, so let's do this. Let's say what exists, because I'm technically like already going through this. So we've said that what exists is there's Twitch event sub, right? And within Twitch event sub, we can connect to Twitch event sub through 2 different types of connections, and that is web hooks or web sockets, and I could say we can integrate with Twitch event sub through 2 different types of connections, web hooks or web sockets, right? Now, if we wanted to really quickly talk about web hooks, right? The pros that I would say to web hooks are, for example, they are completely stateful, right? So what that means is like a request either succeeds or fails, right? What does that mean, chat? What does that mean? Well, it means that you can actually have like more dependable error handling, right? If a request comes through and it, hits your endpoint, you should see that, right? You should be able to see that in your request logs, and then you should also be able to see the processed request in your request logs. You know what I mean? You should be able to see if it errors or not. Like, it's a completely stateful approach to receiving these messages, right? Also, it's scalable, right? And that is because it's request driven, right? And so this is the other part that makes it really simple to use, is that not only is it stateful in the sense that you should know if you're getting errors or not, basically, right? Because it's just going to an endpoint, some kind of RESTful endpoint. But it's also scalable because it's a RESTful endpoint. You just, you need more requests, you scale more servers. And so it's very easily, we should say it's easily scalable, right? And I guess we could say it's, it's stateful. Any other pros to that I can think of? Trying to think. So hold on. We're talking about pros right now, woof dude. I'm trying to think if there's any other big pros that I can think of. I mean, stateful for sure is massively helpful. Scalable is also massively helpful. Schema and stuff, when you come down to it, at the end of the day, it doesn't really matter. You're gonna have to write your schemas for it regardless. Authentication. No, they both have their own forms of authentication. Webhooks will have to have some sort of subscribe system. So will what's it called as well? WebSockets. WebSockets have the same subscribe. Like, you connect to the WebSocket, you have to authenticate somehow. Like, that's a very common thing. Yeah, I think those are really the big pros. So let's talk about the cons really quickly. All right. And this is really where it becomes, very interesting. So the cons is, one of them, Woof said it as well, it's requires many subscriptions, 1 per event, right? And so what that means is that we have to, for each user, subscribe up to like 30 different subscriptions, and all of those have to individually be subscribed. Individually subscribed with webhooks, right? And so that means that, again, if we have more, then we have to subscribe more of those, and that kind of becomes slightly challenging. And honestly, that's really one of the bigger problems, is just that it really is a lot of subscriptions that you have to work with. Outside of that, I don't really think there's many other cons that I can think of. being really scalable. It has made it really easy to maintain, as well as it being stateful. However, another thing is it also requires a reconciliation process, right? And the idea here is that check Twitch regularly. Regurally. Why can I not spell? Wow, I cannot spell, chat. There we go. Excuse me. For missing subscriptions. Sorry about that. And so this is something I've realized is like kind of required. If you don't have this reconciliation process as well, right? Even if you subscribe for one per event, some reason Twitch might like get an event that it doesn't think it was successful. And so because of that, you then have to check Twitch regularly and be like, okay, does every user have all of its subscriptions? Okay, is one missing? Okay, one's missing. Great. Let's go ahead and resubscribe that, right? Which also requires when missing trigger subscription again, right? And so that should mean that basically at all times the users have the ability to, get their events. And again, like being stateful in the sense that we know if a request fails or succeeds, that's very powerful. Being scalable, that's also very, very, very powerful. The downside is really around the management of these subscriptions, right? Again, because a user can have up to 33 of them or something like that. Also, not only do they have to, individually work, but if fail, then handle that failure, somehow. So, for example, if it goes through 33 of them and it only does like 22 of them, some other of them fail for some reason. How do we make sure that the other ones get resubscribed, or those things that are going to be, set up and, handled through the reconciliation, where we say, okay, well, if they fail, then we're not even going to worry about it. We'll just let them get, resubscribed in 5 minutes or something like that. Again, this is just things that we have to consider, especially with experience that we've already gone through. However, this here should give us a basically fully scalable system where if we make it stateful, if we make it easily scalable, and we have this the subscription setup as well as the reconciliation process, we should be able to provide some type of system. Another thing that this does require actually is it also requires a running service, right? And actually not just a running service, but a public service, right? And this means that Twitch needs to, or I'm sorry, this is a con, my bad. So yeah, this would be the last con, which is it needs to be a public service, right? So Twitch can access URL webhook or webhook URL, right? And so this is another one that is a pretty big con when you really think about it, which is we need to make sure that we have some type of public service. Now, if you just say that, like, sure, this can be put into your API service or something like that, sure, you could do that. But like, when you think about it, it could just be one route. It could be one route that sends a bunch of different message types to it, or it could be, a route of regex where, like, it knows how to identify a parameter and then say, like, okay, if it's this, like, you see what I'm saying? Like, it's just, it could just go to one route if you really wanted it to. So having to have a whole public service for just an accessible URL is actually a very commonly brought up problem. And this is why, chat, this is why the next solution was brought to the table by Twitch, and that is WebSockets. Not webhooks, WebSockets, right? Now, WebSockets are pretty cool in the sense that one of their biggest pros are they are low latency, right? So the idea here is that this is a persisted persisted connection to Twitch, right? So because we have a persistent connection to Twitch, we get a super low latency response. A message happens, we immediately get it, right? There's no, okay, the request needs to go out over the internet in the sense of like, you know, it has to go through a load balancer, process through other things. It's like, it's already connected, baby. We just get that message the moment it traverses its little booty through the internet, right? Like, so that's a powerful thing is that it's very low latency. Also, it's I wouldn't say that it's easily scalable. It also doesn't require public service. Right? You don't need to have any kind of public service with regards to WebSockets. And this is, again, actually one of the biggest reasons why Twitch implemented WebSockets, I think, in my opinion, or at least why the community wanted it so badly, was because a lot of people just didn't want to have a public service to integrate with, you know, Twitch events and stuff like that, right? And so that was a big pro, is you know, a user can just like run a service anywhere. And as long as that can connect to Twitch, you're pretty good to go. Can you define what low latency means to you? Under 5 seconds, under a minute, and how is it important is it in your use case? So when we're talking about real time, woof woof, dude, it's incredibly important. Like, we don't even need to talk about times or anything like that. It's just when you talk about real time, like chat systems and like events, like, we just want it to be as performant as humanly possible so we can send as many messages to it and through it as humanly possible. You know what I mean? What's up, Dread? How's it going, by the way? Okay. So it doesn't require public service, low latency. So I'm going to go ahead and jump to one of the cons, which I think is probably all in your heads, is it is not easily scalable, right? You know, I don't disagree with this in all seriousness. I don't think WebSockets are the easiest things to scale. I think there's a lot of different options out there. But if you don't really know how to do it, it definitely can be challenging. I think a lot of times what you end up doing is you just end up making the VM bigger. And I actually do know a few people, like, for example, Fossa Bot, I believe, uses like just a few really big servers. And it works really well. Like honestly, that is a much better way of solving the problem sometimes, is just saying, like, you know what, it's going to be like 2 servers. It'll be failover. It'll be fault tolerant. You know, one will be active, and then if one fails, we just fail over to the other one immediately. You know what I mean? Versus trying to scale WebSockets in a scenario where like all messages can come through and be processed appropriately, and what's called deduplified, basically, or deduplicated, I think is a better word, or, you know, any duplicate messages, because again, with WebSockets, you're just gonna, you know, there are 2 hoses, you're just gonna get hit with both of them. And so, yeah, you have to be able to take those messages and deduplicate them, or deduplicate them, whatever the word is, so that you process it once, you know. Real time doesn't mean the same thing for you in the web context as Bob or on my controller, just trying to help it define so people understand your concerns. Yeah, no, as an organization, remember, this is a product that we're trying to build so it scales as well. And speed is a massive importance. I would much rather have, you know, fast events that come through quickly, and like give what the user expects within the time frame that they expect it, rather than having something that just is super, you know, super scalable, right? That might be slower. It shares the reconciliation problem. Exactly once delivery is physically impossible without cooperation from both nodes, even if it was a single WebSocket. Exactly once delivery is physically impossible. The reconciliation, yeah, you mean a con? It still does require reconciliation, yeah. Reconciliation, and this is fair. So you know, this is a scenario where it's pretty much always going to be there, where we need to verify we are subscribed to event, right? You're gonna have to pretty much do this anyways, I think. I think this is just something that is a good thing to do. So like this reconciliation will still be there no matter what. So I guess in a lot of ways, like what we can actually do now that we see that reconciliation, right? We can just break this off into its own topic, and we could say like, there's no need to compare these two. It's a, you know, there's no difference there. Yeah. Cool. Yes, we are doing a rewrite. Define that time frame. Real time doesn't mean the same thing for you as it. I mean milliseconds. I would want to get the set. I would honestly, in a real time system, I would like to get the message under 500 milliseconds. Yeah, there you go. That's my. I guess that's the best way I could say it. I'd want it under 500 ms. I mean, yeah, one nano. Yeah. Then webhook can't be an option. Exactly. Yeah. Well, I mean, it can. Like, we use webhooks right now, but it's just right now we're also not scaled, right? So it doesn't really matter as much. We don't feel it as much, you know? Okay, so doesn't require public service, low latency, not easily scalable. Any other cons that we can think of about WebSockets? So I guess another thing is it's stateless, right? So we don't know if we got messages or not, right? And this is something that is definitely, like, I can explain a little bit further. So with REST, or a request, I should say, not REST, a request, right? It's gonna at least hit our endpoint, and like we'll get an error, right? Like we'll see something, right? Because it's a request that's coming out, and we are now either, you know, if we don't see a request, then that means like maybe it's our networking, maybe it's a firewall, right? Like something like that. But we should, like, it's stateful in the sense that it's a request that has an accepted "I got you" response, right? WebSockets don't have that at all. WebSockets is in a lot of ways like UDP. You just kind of throw messages at it and you hope you catch them. So we don't really have a way of being like, cool, I got it, you know, let's go ahead and process that. We won't really know if we're getting messages until we like look at the WebSocket and say like, okay, are we getting messages? And then we can kind of see if we are getting those or not. SSE is an alternative. SSE plus gRPC. What is? Do you guys have links, please? Resilience of WebSockets. What's up, Azra? How's it going? Or Ariza. Sorry, or is it Azra? Is it Azra? I don't know. I'm sorry. Wait, what? Oh no, guys. Araz. Oh, okay, Araz. Sorry about that. My bad. Thank you for helping me understand that. I hope I said that right. Yeah, I was about to say, this is Twitch, guys. So I can't use that here because this is what Twitch is providing us. Twitch just provides us a basic WebSocket connection, man. Yeah. It's not crazy. It's a WebSocket connection that you have to do the normal ping over. I think that's it. It's not much. It ain't much. But webhooks works in front end. What do you mean? In FE? In FE? What is FE? Do you mean front end? I don't know. I'm not good with acronyms. Front end. But webhooks works in front end. Yeah, so yeah, it has to be public. A webhook needs to be, because Twitch has to go out and reach you, right? So they have to be public in that regard. Yep. Yeah. No, we're talking about Twitch. Yeah. So we're talking about the WebSocket connection from Twitch, or the webhook message, or I guess webhook request from Twitch, right? So when an event happens with event sub, it's either going to reach out to us with a webhook, or it's going to reach out to us with a WebSocket, right? So there's a few things that I kind of sat down and I thought about this when considering which one of these two that I would be more interested in. And I think one of the biggest cons that I really, Untitled Gooseberry, thank you for the follow. I appreciate it. One of the things that I really found frustrating for sure was definitely the reconciliation stuff. And that's just like, okay, cool. I can write a request to make out like 30, 30 messages or something like that. But okay, how do we make sure they're always subscribed? That was always a challenge. Again, because this is going to be required for both, it's kind of a null statement. So we don't really have to talk about it too much, but I'm just breaking down my experience with webhooks and, the challenges with that. So we're breaking it down right now. I don't know which one of the ones I want to do yet. Yeah, potential. Yeah, I mean, you mean like what we're going to be? Yeah, back end. Yeah. We're not going to be sending it. Sorry, I got you. We're not going to be Well, so here's the thing. We will eventually ship them to a front end, but we will definitely use web hooks when we ship it to a front end. You know what I mean? So if we want to, like, at some point, the front end will integrate to where, like, if a Twitch event happens or something like that, maybe like a little notification bar pops up, in the front end or something like that. That'll be pushed down with a front end or with a webhook for sure. That would be a webhook, yeah. So okay, yeah. So again, the reconciliation thing was a challenge, but again, they're both going to deal with it. So let's not talk about that too much. I think the other thing, I think the statefulness of it was nice. But I will say that, like, I didn't really like having to have a public endpoint. And so I guess what I can kind of say to this as well is what I didn't really like about it is that naturally made me integrate this into my main API, right? And so, like, even though I really had, like, only one endpoint for this, because I didn't really know where else to put this, it did naturally just make me integrate this into my main API. And so I always didn't like this because whenever changes made to the API, it could impact a crucial part of the service, right? And so that was like something I didn't really like about this. And I also, to put it here, didn't want to create an entire service for simply route handling. You know what I mean? Like, I really didn't want to make an entire service just to be like, okay, take a route and send it off to, our event system that we were using at the time. So I would say another really big caveat for me really was around being a public service and just being like, I don't really like that. Again, the statefulness was nice. And the fact that, again, we could scale it was nice, but scaling is also not a real big concern for us right now. And if we really sit down and put on our engineer hats for a second and try and compare the scalability of webhooks to WebSockets, you should be able to scale a WebSocket pretty flippin' far. I think the biggest concern with WebSockets in general is really just going to be around connection as well, right? Connectivity, right? And then basically making sure that you have, constant uptime, right? I think webhooks is better to scale in backend because you can make a service and a queue to it, and basically you secure that your service will scale based on the design time for each message you process. Listen, I don't disagree with you. I don't think it's not as scalable. We're just breaking it down. WebSockets can lead to a port exhaustion. What do you mean? So, like ports we open up to Twitch, or that we open up on a server? Where would the exhaustion be? Too many WebSockets on the same machine? Yeah, I'm gonna be real with you, we wouldn't deal with that. Because each WebSocket would run in its own container, and we would not run out of ports before we ran out of containers. We wouldn't cluster WebSockets like that, Jono. We wouldn't tell the node process, hey, open up another WebSocket connection and do it that way. We would do proper sharding, where we would have multiple services running that would be, again, deduplicating messages and stuff like that. Yes, I woof woof. I'm aware of that, dude. But like, how many ports are available on a server? Like 30,000. I don't run 30,000 containers. Like, come on, guys. Let's be real here. Let's be real. Like, seriously, come on. Like, I'm gonna challenge you guys. That's not a concern. No, it's not a concern at all. I'm never going to run 64,000 containers on a single host. Yeah. So, like, I get you. You're not wrong. It is a potential problem. But reality of it is we're going to structure this in a way where each container runs its own connection. Watch him cry when he runs under the issue. Oh, my God. Listen, bro. If we're running under that issue, I will gladly cry on stream, okay? If you work from home, is it easy to screen in home workouts between meetings so that a secret? No, but I do go to the gym. I just go to the gym. Yeah, I go to the gym at least twice a week. Or I have been lately, and I'm gonna keep doing it. But yeah, as you say that, I'm like stretching out. Woof woof. Again, I'm not saying it's not a problem, my dude. I'm not saying it's not a problem. I'm just saying, is it a problem for us right now? How many messages do you think a single WebSocket on a 4XL like a 4XL machine could be, right? Because that's another challenge that I would give you, or anyone in chat, right? Like, what if I just beefed the machine like crazy? Be possible, you know? So yeah, no, and that's the challenge here, right? So with these in mind, I want to see what you guys think we should do. So I'm going to open up a poll, and I'm going to say, which do we like better? Web hooks, web sockets. All right, here you go. Here's your poll. Remember, vote it. You can also talk about it in chat too, but vote it up as well. Which one of the two that you like better? Now, this doesn't mean it's going to be the one I'm going to use. It just simply means that this is the one that you guys find to be the best. Use event sub in a similar platform. Webhooks felt better for visibility and stability. Easier to stay with hand. Try a public endpoint was not a problem as long as payload was verified. Good day, I missed a Lambda at work on Friday and came back Monday and had millions. Yeah, that's why it's a no. That's why it's like a no. You know what I mean? That's why we're not going to argue over, or talk about reconciliation. We're just going to do it, Because there's a lot of unknown here, the simplest solution is probably the best for now. In the end, the way I see it, that service is pretty much get the event, push it to another queue as simple as possible. Yeah, we're gonna do something like that. We have something else here that we need to talk about before we go further that we haven't even discussed yet. Yeah. Sorry, I'm waiting for the voting thing to be done, and then I will go over our solution. Somebody came in with WebSockets right at the last second. Webhooks. All right, so 56% of you said webhooks. 44% of you said WebSockets. So pretty close, Both solutions seem fine, just that webhooks is really easy to implement. Do you write drivers/strategies in BE? No. I don't think so. I definitely don't do. I don't know what you mean by. I guess I don't know what you mean by drivers and strategies. But again, that could just be techno terms being lost. It's an interface. What's an interface? The service. Okay, sorry, we're getting distracted. Listen pub. Yeah, what's listen/pub the notifications. Okay, hold on. Let me talk about what we're. Hold on. Let me focus on this first. Hold on. Okay, so the majority of you guys said webhooks, right? The majority of you guys said webhooks, right? However, there was a decent amount of you that still said WebSockets. Personally, I hands down agree that webhooks is going to be a much more like contractual way of scaling, right? again, you know that the request comes through. You have the ability of error handling with that, a lot of observability. It's easily scalable. It's just a request at the end of the day. And again, the downside of it being requires many subscriptions. This technically isn't false as well for web sockets, now that I think about this, because here, this technically also requires many subscriptions. The only difference is we subscribe in the web socket here versus we subscribe with a webhook here. So there's actually no difference in the sense of what's it called? Amount of things we have to listen for. It being a public service is a bit of a downer, right? But I think also solving this by simply saying like, all right, we'll have a very simple, API service that just listens for this, maybe we make it a little bit more complex so that we have better, like code around it or whatever. But yeah, like this isn't terrible. It's just, the thing I don't want to do going forward if we were to use webhooks is I want to make sure that this API is not integrated with like another API. Like this has its own service that is dedicated for just handling these things. You know what I mean? I don't really want it to be anything else. Interface Twitch listener on channel. Oh yeah, sure. Yeah. If you're talking about with web sockets, yeah. Yeah, you could do that for sure. You have WebSockets and webhooks, but what about WebAssembly? Hey, how's it going, Razor? Webhooks also run into edge cases more often, which is a good thing thinking in Chaos Monkey terms. Yeah. Other integrations will probably use webhooks anyways. You might create a single webhook service or make a somewhat templatable service. So let's talk about that really quickly. That's actually a very good point. Let's talk about this really quickly. So we can also say existing connections, right? So we have a few of them. We have Discord, right? And we have Twitter, right? Now, Twitter doesn't use this at all. So technically we can get rid of it, right? Twitter only sends messages, right? Messages, no receiving, at least yet. We can say at least yet. Now in the future, there's a solid chance that we could have Twitter integration. So if we were to explore that just for a second, Twitter web hooks, I'm guessing is probably what they have. Do they have WebSockets? I would imagine they don't. I would imagine these guys only do WebSockets or webhooks. Yeah, they only use it looks like they only use webhooks. So Twitter in this case would only use webhooks. Not receiving yet. If we do, it would use webhooks. Okay. Discord listens entirely on WebSockets. There are webhooks, but in all seriousness, everything we need from Discord is pretty much entirely on WebSockets through bot, right? Through bot service, right? And so this is basically a service that opens up a connection to the server and listens for all of the events. This is really the best way, I think, in my personal opinion, of doing this. Also, I don't think you can get everything. So like Discord webhooks, I don't think everything comes with webhooks. Oh, this is just for sending them. So it looks like that's just for sending them. Webhooks are lower for way to post messages to channels in Discord. They do not require a bot or user. Okay, so yeah, these don't even, yeah. So it would, for Discord, it'd be 100% listens entirely on WebSockets through a bot service. What else do we have? We don't have it yet, but eventually there will be more YouTube integration. YouTube, I know YouTube has a WebSocket. YouTube WebSocket. API. Wait. Connect to YouTube WebSocket API. Is there not like a flippin' YouTube thing? API reference. Oh god, I hate Google. Live broadcasts, live streaming API. How to schedule live broadcasts and video streams. This looks like YouTube. Okay. Dismiss. Go away. Okay. YouTube data, subscribe buttons, analytics, live streaming, schedule, play YouTube. No. This can't be it. There's like bots and stuff, right? Google APIs, Explorer, YouTube. YouTube. Provides access data such as playlists. Live. Does anyone know? Live chat message overview. Oh, but that goes to it. Client libraries. JavaScript. Auth. Nope. Getting started. Init. This does not look like anything that would help me. Oh boy, does it really? So here's a question. How would you get like, okay, here. YouTube API get go live notification, right? Like if I was just trying to solve the get like go live notification problem, right? Subscribe to push notifications. Oh my God. Okay. The YouTube data is pub sub hubbub, a server to server publish subscribe for web accessible. Notifications are pushed out to subscribe via HTTP webhooks, which is more a service than polling solutions. Okay, so this is webhooks. So it would be, at least for this, it would be webhooks. So YouTube go live / offline would use webhooks. Subscribe to push notifications. What all do you get it? Does any of the following: uploads a video, uploads your callback receives, uploads a description. I would imagine whenever a video is created and it's a stream, that's when you would know that it's a go live, right? Work with channel. I guess the only other thing I would like to know is how do you get chat messages? YouTube live chat messages API. Resource represents the chat resource can live chat is a feature after the end and no chat available. Okay. Wait, is this like a wait? Oh God. Wait, do you pull this do you actually have to pull this thing? Please don't tell me you actually have to pull this thing. Am I correct that you pull this thing? How long your client should wait before requesting additional results? So this is how you do it. Oh my God. Poll happens. So, okay, so if you want to know, so live streams is the same thing. So it's all polling, really. Anything Really? Okay, so honestly, no. YouTube would not be. All live events would happen through polling. So there's no webhooks or anything like that. Twitter sends it poll and run in limits. Yeah. Holy. Oh my God. That's it. That's interesting. Yeah. I mean, it makes it so you're not, it's a very interesting approach to say the least. Google's always doing things their own way. So we've got Discord, Twitter, YouTube. Can any of you guys think of anything else that we would integrate with? I guess TikTok? I don't know what we would do with that though. Hang on. Oh God. So it looks like they have webhooks as well. Events. Webhooks let you subscribe to events and receive. So it looks like TikTok would use events as well. Okay. Sends all events over webhooks. Reddit has live streams as well. So okay, actually here there's one we're totally missing that we're not thinking about, which is Twitch. So event sub, we don't know yet, right? Chat, however, is going to be through chat is all handled through WebSockets. Right? So event sub we don't know yet because we haven't made a definition on what this is yet. I don't know if we care about Facebook just yet. I think these would be the big ones that we would care about right now. You can also do Twitch chat through IRC. Well, IRC just upstreams through, like, IRC is the WebSocket. They just upstream it through to the WebSocket. But yeah, you could through WebSocket or IRC, right? But basically, this would be a constant listener, like, you know, through IRC bot service. Right, so that is one thing that's notable about these two, is that these are really, bot services, things that are always going to listen for like events entirely. You know what I mean? Again, Discord's just a messaging service, so that makes sense, right? Twitch, being a messaging service, at least through the streaming part, is through WebSockets, or, so again, these, maybe we don't compare these because these are something that will, no matter what, require to be online all the time. Whereas like TikTok, Twitter, and YouTube, right? Like these, well, actually YouTube doesn't, but so TikTok and Twitter at least would require webhooks. Yes. Isn't Twitch chat built on our? It is, but you can get it through WebSockets as well. All right, I'm gonna pose the question again, chat, one more time. Which one should we use? Webhooks or WebSockets? Now I'm posing it again based off of the existing connections knowledge that we know. So this is why we have to reevaluate the question over and over, right? We've said that Discord and Twitch have bot services that entirely focus on chat and solving chat problems, right? So those are going to be things that are listening all the time. But when we're talking about like events, right, which may still be, messages are still events, but when we're talking about other types of events, we can get those through webhooks essentially, and then YouTube just being like weird. So it looks like no matter what, TikTok and Twitter would require webhooks, right? Whereas YouTube, Discord and Twitch could be completely WebSocket based. Yeah. Now, here's something I will say. I don't want to couple the chat to like the chat handler stuff to this, right? So when we do the bot service, it's going to be something entirely different. It's not going to be the same service, right? Because we don't want our chat messages coupled with our like go live notifications and stuff. We don't want that. Hang on one second, chat. Hang on. Sorry, I'm back. Sorry about that. My bad. Hi. So you guys picked WebSockets, and I don't necessarily think that that's not a terribly bad, solution. I do wonder, again, like if we do the approach of webhooks, we think about this for a second, right? Like here, let's go back to here and let's break this down for a second, right? So we're going to have the Twitch API, which bam, here's our Twitch API, right? And then in the circumstance of it being, not a WebSocket, we say a API or a public API, right? What's going to happen is basically they're going to come out directly to us, right? And they're going to message us whenever there's a new event, right? Once that happens, now again, we don't know what this is, so we'll just say that this is our event handler. Like, we don't know what this is yet, so let's not try and define this in any way, shape, or form. We just know that this is going to be our event handler. And so basically what happens here is the message then gets passed off to the event handler like this, right? Cool. Okay. So the event handler, bam. So what would this require? This would require, us hosting this somehow, making sure that it's public as well, which think about it though, and I do want to be clear, even though public accessibility may seem like it's pretty trivial or pretty simple, it's not sometimes, or it's not most of the time, especially if you want to do it the right way. And one of the biggest things I mean by that is making sure that it's like SSL, right? That you have a load balancer, right? So it's not in this scenario, like this isn't really an accurate representation. So let's kind of zoom this out a little bit more. Technically in this scenario, we would also need a load balancer, right? So maybe we have an application load balancer of some type, which goes to it. Oh, come on. I don't know why it's making the color of all of my lines white. And then this load balancer now goes to this as well, right? And then there's our event handler system. Or, and actually, here's another thing too, right? If we wanted to talk about, scaling, how do we scale it? Okay, well, we just add another one, right? Bam. Just like that, right? And that's basically how we scale it. Now, in the WebSocket approach, this actually becomes a lot easier. This is just a WebSocket, running anywhere in any cluster, right? And what's happening is the Twitch API and the WebSocket are basically just in constant communication with each other, right? And so this becomes like a double line, basically, instead of like just a forward line. This becomes like a back and forth line, right? And then we just have our event handler. No, not in the initial implementation. What is the current load? The load balancer, no, this isn't a pre-optimization. This is just plainly, if we're hosting this in the cloud, we're going to have a load balancer. The load balancer is going to be our ingress to all of our containerized applications. So it doesn't matter. Like there's going to be a load balancer of some sort, at least in the sense of that. Yeah. The sense of the WebSocket, there's no load balancer needed, at least in the initial implementation, simply because the WebSocket just, yeah. All right. Hang on one second, chat. Cool. Oh, excuse me. Sorry about that. Cool. We're good now. I had to make sure that we were like muted and everything, but we're good now. So in this case, no, we're not going to worry about that kind of like we're not ready or worried about that necessarily just yet. So yeah, like we're good. We're good. The only thing here that would really matter is the connection to the Twitch API via the WebSocket, right? So, okay. So, and Keeb, I'm going to be fair, dude. Right now, we don't have any need to worry about like load or optimization or really like it. We don't have enough traffic to where that's really that big of a concern. So, there really shouldn't. The only thing that we're kind of exemplifying with the load balancer here truly is that we need some type of ingress, some type of ingress that enables us to allow the Twitch API to access our services. Right? This can be a proxy layer, this can be whatever, but at the end of the day, we need some type of ingress that the Twitch API can access. That's also managed uptime, right? Like we need to make sure that the ALB is always online as well, not just the service. So there's a thing to consider here where like both of these things need to be make sure that they're managed online, all that stuff. Cool. Just making sure I'm not missing anything for the meeting. And that I am still muted, which I am. So we're good. So yeah, looking at this, like, I'm going to be real. Like, I'm still kind of torn, right? Like the REST approach is, I think, one we know about, we know how it works, and we know that it's like the tried and true. Right? Like, I think that's the best thing I can say about the REST approach. The REST approach is just kind of like the tried and true. Like, we know that it's going to work. We know that it should be scalable. And we know how to handle it because we've technically already handled this problem before. Yep. Yeah, you're not wrong. You're not wrong. Hang on one more second, guys. Cool. All right. There's a big presentation that's going to happen now that I don't have to worry about. At least directly. I can watch it later. We're in it. Yeah. This is a bit devious activity. Yeah. It's the reason why I'm in it is just to make sure that I'm paying attention in some regard. It's the tech all hands. So, I kind of want to make sure I'm there. My premise is that it's better to super lean and rewrite MVP. And sorry about scale rest later. Just worry a simple binary receiving event stubbed out to an event handler loop. Like it seems like. So are you saying Keeb? Are you saying WebSocket? Is that what you're saying? WebSocket? Are we in work? Oh yeah. Legend has it. So yeah. No, I feel you. Is that what you're saying, Keeb? WebSocket? Like an interface of some sort for Ingo. Oh, I could actually use this. If that's the simplest approach now, yeah, it is. Yeah, no, it definitely would be. Okay, so I think we go with the simplest approach. I agree. You guys have given me enough of a reason right now to look at this and say, like, you know what? Let's just wire up a WebSocket. Let's get a connection to Event Sub, and let's get some messages being processed through it. That does make a lot of sense to me. I think that another reason why I don't mind doing the WebSocket as well is because, like, in all seriousness, there's other problems that I want to solve at the moment. Well, so woof. Okay, woof. I need you to pay attention to me for a second. I mean, I know you're watching, but just listen here, dude. Okay. Your perspective right now is entirely focused based off of past experience, understanding, and you're comparing that to what we're trying to implement, which is fair, and that's fine. And trust me, in the back of my mind, I'm not thinking, okay, at some point we might have to move this to a RESTful endpoint once we try dealing with scale, right? I too am trying to consider how do we deal with like uptime, how do we do with like more than one instance of this running thing. Like I get it. However, at the moment, like right now at the moment, this is a small piece to a much larger puzzle that we're trying to solve, right? All we really care for this thing's purpose is to be an interface between Twitch and the thing that handles our events, right? And as a matter of fact, this part here, we haven't even solved for yet, right? Like, we don't even know how we're going to handle events or anything like that, right? So this isn't going to be the thing that, you know, receives the message and processes it. It just simply takes whatever we get from Twitch and then passes it on to where, you know, where it needs to be processed. All but one platform support webhooks. No. Sure. But we don't, like, that's, what's your point? Like, just because also more than one platform supports it doesn't mean that that's what we're going to go with. Like, we're trying to solve the problem for just Twitch. We were just trying to evaluate everything else. Is this one of those things where conversation takes longer than implementation? Sometimes, yeah. Yeah, in all seriousness, like, we probably could have a WebSocket connection already set up in some regards and already listening for events. However, we're doing this because we're deep diving a bit here. And also, we're not trying to jump into implementation just yet. We really aren't. And the reason for that is there's a much bigger problem that we need to talk about. And this is just like a small part of it. This is what I meant earlier when I asked you guys, do you want me to give you the solution first, or do you want me to give you the breakdown first? Right now, right? And woof woof, I think this is fair to agree with. You know, if we wanted to try and put something in production that could listen to Twitch API messages and pass it on to our event handler, not caring about scaling, not caring about some of those other things just yet, the WebSocket approach would be the simplest. I think we can agree on that at least. When we talk about other things, like, again, scaling and things, yes, those become more challenging. However, there's a much bigger challenge here that we haven't really discussed, right? And I think it's more so around the one with the question mark, the event handler, right? Now, again, whether we get this through REST or we get it through WebSockets, we need a way of processing these messages in a way that makes sense, right? And we also need to process these messages in a way that it becomes parallel, right? And so what that means is like, for some events, we want one thing to happen, and then we want another thing to happen right after that other thing happens, right? And I know some of you guys have been like, oh, use a queue system, or oh, use this, or oh, use that. But this is another problem that we have to solve before we completely figure out how. Hold on. So I'm going to be real with you, Woof Woof. I read what you just said. Hear me out, though. Think about separation of concerns, right? I could join these things together, put it all in one service, and call it a day. However, if I do that, then I have to worry about when I make changes to other things, if it will impact those things too, right? We're trying to really make something that is just separated, because at the end of the day, when I make a change to this, I only want to change this. Like, we've said the high priority of the event sub and events and other things. We really, like, in all seriousness, we don't want these systems that are so low level and so crucial to be connected to other things. You could template the service. Yeah, I mean, we could. You're definitely not wrong. But like, I also think in the same sense too, like, can you choose agnostic interface without having setting more than one external source? Sorry, what do you mean by that? So you can copy, paste, and change it quick and dirty. I mean, I just need you to open your mind a bit, buddy. I need you to open your mind a bit. I feel you. I hear you out. Let me take you down this path. All right. Let me take you down this path. I think, yes, it is my system. I'm aware. I am very aware. And I do think that, again, the bigger thing that we have to problem solve here is not this. And in all seriousness, moving from this to this really should not be too difficult, right? I thought this was my system. No, but in all seriousness, I also think that it would not be too difficult to move this from one thing to another. That's fair. It's our system. Yes, it's our system, comrade. But yeah, we do want to separate this. We do want to separate this, and we do want to handle it, the best way that we can. So I think that right now, regardless of what we pick here, right, we have another problem, which is, again, we realize that we want to process messages, but we also realize that we want to process messages like after messages. So there's two things that we could do here. I'm going to get rid of this for a second. I'm going to get rid of these for a second. I'm going to get rid of this for a second. And just for the sake of like whatever, just making my life simpler, we're going to get rid of this. We're going to get rid of this, and we'll do both of these, right? So let's just get these together and we'll map them both. So no matter which decision we pick, we need to send what we want to do. And I'm going to draw the line here first so that you guys know. We need to send specific events. So like this event here, this little guy here, we want this event to be the, event sub, or stream.online, right? I think that's what it's called. I think it's called stream online. So this stream online message, I appreciate that. This stream online message here, right? This message is going to be whatever this processes or this processes. This is what's going to come out of this, right? So there's a few things that we could do here. Like, for example, we could have this go to a queue. We could have this go to a direct Lambda, right? We kind of want to figure out what our goals are. And so we'll say like, go here, what our goals are. Or we'll say, what are our goals, right? And here, I'll do this as well. Suggested tech. What did you say it was? Into AWS cloud events. Cool. Again, trust me, we're already kind of thinking the same things. So yeah, what are our goals? So our goals are to receive events. If I can spell right. Receive events from Twitch event sub individually. Right? We want to receive events from Twitch sub individually. We want to then run a single process for each event, right? So what we really want to try and do here, my personal opinion, is we want to try and make this serverless, right? What I would rather do, instead of running more services in the cloud, I would prefer to run things when they are needed and keep things running 24/7 only when required, like a web socket or API, or we say like an API or web socket, right? We have the ability of using serverless at our fingertips, like why not? Why not go ahead and lean on that to the best of our ability? You know what I mean? Cloud Events is not related. Yeah. No, Cloud Events is used by Knative. Yeah. But how will I run my crypto malware if it's not? Yeah, exactly. Yeah, no, I think this is another big goal here is we want to receive events from, and then, we want to process those. Another thing we want to do is we want to run multiple multiple tasks in parallel. Right. And so what that means is like one event can trigger like one trigger, right? And then another trigger, and then another trigger. And like this can kind of go on, you know, forever, right? So that's something else that I want to mention is like I want an event basically to populate a trigger which could trigger, and this is like super important. If we can do this, then we have a lot of flexibility with the kind of things that we can do with Twitch events. Are these events for single users channel? Or are you aggregating? Yeah, single users channel. Yeah, single users channel. Yeah. Okay. Is there anything else that we can think of here? So receive events from Twitch event sub, right? Thought I was unmuted for a second there. Run a single process for each event, right? And then run multiple tasks in parallel, right? Oh, I'm sorry. Not parallel. Sequential. Sorry, in sequence. My brain went dumb there, Fred. Sorry about that. Thank you. Right, so we want to create a sequence, right, where one event can trigger something else, which can trigger, run multiple tasks in a sequence. Yeah, sorry about that. I looked at it and I was like, what? And then I went, oh God, I used the wrong word. My brain, yeah, I went, you know, backwards. So persistent event stream can have layers. Yes. Wait, what? What are we talking about? Okay. So this gives us a lot of power, right? And another thing too is like, I want to be able to run, like I said, like one event, for example, and I'll give you a good one here. Like, okay, so when a go live happens, the following steps must occur. And this is a good example of what we're trying to do with our event system. First, we receive the event, right? After we receive the event, we download the Twitch preview image, right? And what that is, if you're curious what that is, that's literally this thing. Oh, come on, man. That's this thing, right? Like here's ours. This is our preview image right here, right? So this image gets downloaded, and the reason why that gets downloaded is because it gets injected in this announcement, like you can see here, right? So that we have a visual way of showing people that we're live, basically. So this is the first thing that happens as right now, at least. We receive the event, and then we download the Twitch preview image and store it in S3, right? After we do that, then we generate the Discord notification and send, and then we generate the Twitter notification and send, right? Now these two are parallel to each other, and so we'll say run the following and these are run in like actual parallel. This time when I say parallel, I mean parallel. And so this is when we generate. So basically, oh shit, hang on a second, guys. One second. Cool. Sorry. My team manager's doing a demo on something, so I wanted to make sure I tuned in. So yeah, so this is a really good example of a scenario where we have like one event that actually does a lot of interesting things, where it has one thing it needs to do before it then runs things in parallel and stuff like that. So we have this really interesting case where like some things can just run once and we don't really need to care about it. Other things can run, in parallel next to each other and we don't care about them. But we want an interface that allows us to kind of do both. You know what I mean? This is where, and I'm going to be fair, if anyone was talking about like queues and stuff like that, queues can become very challenging with this. Especially when we talk about later on being like, okay, I want to add more things. There's like downstreams. You have to send it from one queue down to another queue and things like that. And so queues in this regard can definitely become a bit challenging. I'm not saying you can't do it. I'm just simply saying that Yeah, it becomes tougher for sure. And so yeah, so we have this scenario where we want to run, things in parallel as well as things before things while receiving events. And then we want to also be able to run a single process for each of those events. So let's kind of map this out about a bit here. I think we know by now for sure that we're going to be running a Lambda, and say, for example, if we wanted to map this out exactly, we could take this and say like, okay, here's our Lambda Twitch preview, right? Now I said that I want to break this down into a scenario where each step is its own process, right? So right now what we do is we actually take the Discord step, and the download for the Twitch embed or the Twitch preview is a part of that. You know what I mean? And we don't really want that. What we want is we want this function to fire on its own. And then after that, we have like a Discord message Lambda that happens after that. Like this is the real power of like microservices, right? Because then what I can do is I can say, if I always hit this one, I always get the same exact response or expected response of, all right, I get a preview downloaded and stored in a bucket. Versus this one, if I send something to it, I get a message sent over Discord, right? Too far. Wait. So multi-tenant, or you plan to have Lambda scope per tenant? What do you mean by that? Yeah, what do you mean by that, Wolf? I think I don't fully understand. Like again, we're not talking anything really. Well, I mean, I don't. Yeah, again, unless you're talking about like, yeah. What do you mean by multi-tenant? Oh yeah. These are going to be general functions, man. They're going to be low level enough to where they can process any Twitch preview and any Discord message. We don't have any, like, that's not a concern at all. Yeah. I like Lambda for unit logic. I feel like the flow diagram should be captured by event streams, and the topology of that can somehow enable you say do once. Right. Yeah. So yeah, they can definitely be reused. Like again, any person, like yeah, they're just going to be low level services. And so then we can say, all right, well, we also have our Twitter message. And again, sorry if I'm not understanding anybody correctly or anything like that. I'm trying. So this is now what we can call our 3 lambdas, right? We have our Twitch preview lambda, which is going to store our stuff in S3 for us, right? We then have our Discord message lambda, which is going to, after the Twitch preview happens, send our Discord message for us with that image embedded. And then the same thing for the Twitter message. So we could say kind of, if we want to structure this a little bit more, maybe it looks something like this, right? So if we wanted to, right, we could say like, okay, this lambda goes like here, and then like this lambda fires this lambda, right? Like if we wanted to, is what I'm saying, chat. If we wanted to, we could do something where it's like lambda jumping, where like this fires this and then fires that and so forth and so on, right? However, there's a much better way of handling this, and I'm going to show it to you. Now, there's actually a couple different ways you can handle this. For example, if you didn't want to do a lambda to lambda approach, right? What we could do instead is we could say like, all right, well, let's get a queue. So we'll get an SQS right? And then we'll put each lambda behind a queue. Hang on, sorry. All right, let's just like duplicate this to make my life easier. Attach U to U. Attach U to U. right? We could take this approach. Okay, cool. Let's look at this approach now. Well, now what we've got is we've got a bit of a scenario where if we move that over a bit, there we go. Move this over a bit too, here, like that. There we go. If we use this, then we say like, okay, we first send this one to this queue, right? And then this one, I guess, like fires this queue, right? And I'm doing this to show you guys the flow of traffic and how it works, right? And the same thing here, right? And if you guys know what, I think I saw somebody in chat say like step functions, like, yeah, this is basically like, well, not step functions, but like, yeah, I guess step functions. This is kind of similar to that, but with queues, I guess. Sorry. So hold on. We're not there yet, chat. We're not there yet. Do Quirk users get info on which notifications have been sent, which state they're in, say Discord message failed? It's not something we provide yet, but it's something we could provide. You know what I mean? So here's the challenge with this one, chat, is whenever we need to add something new, we have to like inject it into this chain here, right? And even though you can do this, like with a few of these, when you say that there's like 30 of these things, injecting something new into this chaining like this can become very challenging. And so this is a scenario where like this is really, again, like you don't, you know, if you've got a couple of these, this really isn't that bad. But once you've got like, say like 30 of these or something like that, you've got to handle queue. You've got to handle dead letter queues for each one of them. Yeah, no, don't worry. We're getting there. So that's something I want to point out about this is this is like a, you know, and if something breaks here, then we don't have anything else. Like, how do we know where this happened? You know what I mean? Yeah, exactly. There's a lot of challenges here. I think you guys are on the same page with me with regards to why this is not necessarily a great approach, right? So we've talked about a few approaches. We've talked about directly going to lambdas and how having lambdas like go from lambda to lambda. We've talked about queues and how queues jump from queue to queue and stuff like that. My coworker's doing a demo. Sorry. Come on, demo gods, be nice to him. Okay. So anyway, so yeah, so you know, if this isn't going to work, which is fair, we'll go ahead and get rid of this and let's kind of reassess this one more time. Right? Oh yeah, of course. My team I love my teammates. They're awesome. So okay, so we've talked about lambda to lambda. So we know, let's say a couple things to be true before we go further. Okay, the first thing to be true is that we know we want our unit, at least in this regard, to be lambdas, right? Cloud serverless functions that we can easily just like have specific pieces of code to that handle specific processes, and we can easily trigger these processes to handle these things, right? I think we can all agree on that. Yes. Okay, cool. So we like the idea of lambdas, and we need a way of handling the events in our event system. So again, where like a stream online happens and we can process it the way that we need to. Now, if we can't do the queue-based approach and we can't do the lambda to lambda based approach, there is another system out there that we've not talked about yet, but Quirk actually does have this, though it's not implemented as nearly as well as the design should be, right? And this is what's called an event bus. The idea is that when we have events and events are being maintained at a scale where you have things that you want to happen one after another, you have things that you want to have happen together, and you also want this really, really well granular made design of like, you know, individual units doing individual things. Event buses can be very, very powerful for that. The main reason is because it's all around the concept of events themselves and what happens when events happen, right? So you basically deconstruct the concept of a queue, so or more so of just like, hey, I'm gonna take some information, run it, and run the next one, FIFO, first in, first out kind of scenario, right? But what I really want to do is I want to, whenever an event happens, I want to react to that, right? And it doesn't matter how many things I do to react to that. I want to react to that event with that thing happening, right? And then if that event finishes, then I want to have another event that happens when that event finishes, right? And so the idea is that this event bus is a place where we send all these events to, and then as an event happens, another one gets triggered. Now, you guys might actually remember this, right, with our recording pipeline, right? And this is what we did before, where what would happen, and this is an example, I actually have an example of an event bus here for you, with the previous recording pipeline implementation, if I can fix this stupid thing. There we go. What would happen, you guys ready for this, is we would have here, let me zoom out a bit so you can see all of it. There we go. We would have what's first and foremost is our publisher. This is where everything starts, right? And this is me showing you an example of how an event bus works. Normally it has a publisher of some sort, right? So a publisher will send your initial event, right? That initial event goes to this can be pub sub, this can be event bus, it can be whatever. But the main point is that it's a system that enables you to listen for events. And then when those events happen, basically handle them any way you need to. So what I did was I had a publisher that send a created event, right? And when this created event went to PubSub, it initially forwards it to the queue. However, in this case, what it's doing is it's forwarding to the created queue, right? Or essentially the create queue. When that happens, that triggers a convert job, right? So I am using queues here as well as like a helper to kind of distribute workloads. And so the idea is that once the created event happens, we trigger in a queue a worker to be able to then handle that specific workload. Once that worker finishes, it triggers a converted event back to the pub sub, right? And so this process of looping back around basically keeps happening, where once converted is triggered, then converted gets sent back out to a queue, where that is then triggered to archive. And then when the archive is done, the archive sends the archived event to the pub sub. So the idea is that we can use this event system as a way of saying okay, when an event happens, just do this, right? And then we could say okay, we're going to have this event happen first, and then we're going to have this event happen next, and then we're going to have this event happen next. And then as these things happen, we trigger the jobs that we need to, right? And so the idea that we could have here is, and this is where right now I'm just going to put something here as a thing. Sorry. We're just going to call it our event bus for right now, right? What's going to happen is Stream Online will go to the event bus, right? And then the event bus is going to emit or basically handle what happens when Stream Online happens, right? And so what are we going to tell it? We're going to tell it, all right, well, listen, when Stream Online happens, I want you to trigger our Lambda preview, right? Because that's the first step in the series. I want you to trigger the Lambda preview. So what's that going to do? That's going to go out and it's going to, download the image stored in the bucket. Once that happens, it will be done. So once Lambda preview finishes, we'll get that event in the event bus. We'll be able to see, okay, cool, Stream Online happened. Now, again, I don't think we actually have to send this back to the event bus. I think the event bus just knows that basically it finished. So it's, it's going to say that this finished. But once this finishes, Then the event bus is going to go out and it's going to trigger anything that happens for the event of, hold on. We'll call this one stream online preview, right? So maybe that's the one for when the preview is finished because it's like a specific event for that, right? So once stream online preview triggers, then we can trigger both of these. Right? And we just keep doing that. We keep doing that circle where once Discord message happens or Twitter message happens or stream online, Twitter message, or maybe what we do is we say stream preview, right? I don't know, whatever. You get the idea. How we name it and how we change essentially the naming and whatnot doesn't really matter as much as it matters that you guys understand how this flow works. Again, the idea is that when we send things to an event bus, we can easily just say, hey, event bus, when this happens, I want you to do this, specific thing. I want you to run this specific task, or I want you to, whatever. And so, yeah, in this scenario, what we can do is we can easily just say, hey, event bus, when stream online happens, first handle here we'll do stream.online. Whereas if we go back and we say okay, once stream online preview happens, once this is done, then we send out our Discord messages. I think you're gonna like working with this pattern. Oh yeah, no, I agree. I've used event buses before. I'm pretty versed in them, and I do like them quite a bit. I didn't know about them as well when I was doing the initial implementation of Quirk, which is why I want to sit back here. So before I go further, is anyone confused on what I'm talking about here? Does anyone understand why an event bus as the central place of receiving messages and stuff makes sense? Does that make sense essentially? And again, we can use this very simple patterning of just saying once one event finishes, we trigger another event, right? Trigger another event. We hook into that other event, right? And we just keep hooking into those events, until we're finished processing everything. Looks like a state machine. I mean, it kind of is. Yeah, it kind of is. Has the same concept of having a switch of events and stuff in that. Event bus means you have to define if you want to use orchestration, workflow, or choreography reacting. In some cases, you want to in other cases, you want the either. So I mean, woof woof, I think we're just going to be doing reacting. I think that's the one that you're talking about. To be fair, I don't even know if I fully have gone that deep enough into event-driven systems to be able to know some of those terms, but I think we're doing the reacting one, yeah. You could have an event, yeah, and that's why the reacting one, if that is what we're talking about, at least that's why doing that where it's that's what we're doing here, Taro, right? When the stream online event happens, right, we just fire the preview lambda. But once the preview lambda finishes and we send a stream online preview event, right, then we can fire the Discord message and the Twitter message in parallel, right? I think there's good patterns to avoid it. I can probably find the top. I think it was from... I'm trying to... wait, what are we trying to avoid? Sorry? I'm going to sit down. Can somebody redeem the sit down, dude? I would really love to sit my butt down for a little bit. If not, I'll redeem it, damn it. Oh, thank you. I've been standing for 2.5 hours, man. Nobody lets me sit. They only want me to stand. I actually do need to make a link for that. Orchestration Saga's process manager that defines the events that fire on success failure. This is fundamental basis of step up functions. Coro, your consumers define the order of events. It's not defined by a process manager. So usually people start off with Coro until it becomes messy. Yeah, I think we're going with Coro, I guess. That's cool. If you guys have links or anything to share on this stuff, I appreciate it, by the way. All right, so let's build this out a little bit further because there's a couple of other things. Yeah, please link any of that stuff. All right, cool. Just checking in on the thing. All right, so again, looking at this, like this is a good start to what we have. However, there is a couple of things that we can add to this, or at least one thing in particular that we could really add to this, which is like, what is this event bus, right? Like, what's the thing? Like, we have our service of some sort, whether it be, a RESTful endpoint or a WebSocket. Again, we don't know which one we're going to do yet, or at least maybe for the prototype, we'll do the WebSocket and then we'll move to the other approach. I don't know. Again, we don't know yet, but all I'm trying to say is like, what is this? Chat, what do you guys think this, if we're talking about Amazon now, what do you think we could use here? Do we create our own service? Like, what do you guys think? Oh, sweet. Thank you. Sweet. Perfect. I love reading things. EventBridge. Okay. So I believe EventBridge is powered by SNS underneath the hood. So, anybody else? Any other suggestions on what we think this could be right here? Anybody else? Cool. Okay. So Robert Tables was correct. Event Bus is actually a great solution that we could use here. The main idea is that we really, again, I don't want to have to manage. If you guys have links to other things too, like, share it with me and I'll take a look at it. Like, the biggest goal with any of this, Abbott or anybody else who may have any other suggestions, is with Quirk 2.0 is what we're going to call it, or Quirk Mark 2. That's what we'll call it, Mark 2, second Mark. With Quirk Mark 2, it's really going to be about the less we have to host as possible, right? Now, when we're looking at these systems individually, right, we know that there's a Twitch API that exists that is managed somewhere. We don't manage that, right? In the sense of a RESTful API, there's a load balancer that is managed. We know we manage that, right? That's something we know we have to manage, right? And then there's also the service itself, which handles those requests past the load balancer, which we also know we have to manage. Same thing with the WebSocket approach. We don't manage Twitch API. However, in the WebSocket approach, we don't manage an ALB, or at least, a public-facing ingress of some sort. That's, again, what we're just trying to define here is the ingress, right? Public ingress is what we can call that. There's no public ingress here with managed uptime. This is and I will say this though, this is still managed uptime, right? Like, even though we have managed uptime till, we're still going to have it here. And that's a very valid point to make, which is like, uptime is always going to be a problem, right? So we can even get rid of this technically, because no matter what, it's either got to be up here, right? Or it's got to be up here, right? Otherwise we won't, yeah. So the next question we have to ask ourselves is like, if we want to be creating Lambda functions, like, what else do we really want to be caring about, right? Do we really want to care about, how our event bus is hosted and the software that's managed for it and all that stuff? Or do we just want something we can configure and send events to, right? And my personal opinion is we want to configure something, and just subscribe our events to. And so the idea here is that we could lean on event bus essentially. And I've actually built this whole thing out now, and I can show you entirely what I'm kind of thinking about for this solution. This is what I was going to show you guys originally. So the idea here, this is what I built out yesterday on my iPad last night, actually, while I was reimagining what I think, how we would handle Twitch events, or at least the online notification. How would that look, and what would that look like? I think it would look something like this. Don't bring it up. Don't talk about it. All right, just ignore the DynamoDB. We'll talk about it later. Ignore it. Okay. Ignore it. The main idea though is that we have our Twitch API, right? And our Twitch API is something that we don't manage, right? Once we have our Twitch API, we then want to create a virtual private cloud, of course, because our virtual private cloud is going to is going to host our Lambda functions, right? It's also going to host our containerized, whether it be a front end or whether it be a back end or... Cool. Meeting's over. Awesome. All right. So yeah, whether it be, a WebSocket or RESTful approach, whatever, like it still doesn't matter. It's still going to be something that's going to be hosted somewhere. You know what I mean? Then yeah, like this is pretty much going to be the same. So that means that we are going to have a Kubernetes cluster of some sort, right? Some kind of EKS cluster. So what happens is now we say like, okay, we've got our VPC set up. We've got our EKS cluster. How do we want to manage these messages? Well, we say, okay, in the WebSocket approach, we take a WebSocket, we connect it to the Twitch API, we start getting those messages. Now, the reason why Dynamo is here, chat, is I simply want to try it. That is it. When we talk about serverless, true serverless, chat, there's one thing that's always flipping consistent, which is there's something that's got to be running 24/7, running your database. Always. And I would really love it. If I didn't have that problem. Now, don't get me wrong, chat. I understand there's other ways of solving that problem. However, if there was actually a fantastic serverless database solution out there that I could just pay for data tables, read transactions, or like literally just pay for what I use, not have to say, all right, well, I'm cutting a friggin', $30 cost no matter what, right? Yeah, okay, I'm down to look at Abbott. Yeah, no, listen, I'm down, whatever, or not look at Abbott. I'm down to look at like any of these things, right? The main thing is, and I want to be clear, okay, Abbott, and for anyone else who starts sending me things too, the goal of using DynamoDB or any kind of cloud-based solution is to go with a serverless database solution, right? Is to see if it's possible to go with a serverless database solution. If it's not, then we'll just go with RDS, call it a day, be done with it. Right, that's just plain and simple facts. Like I'm not gonna overly complicate everything just yet. You know what I mean? But I am interested. I am interested. You know what I mean? And so that's why I want to explore this. Now again, for all your butt cheeks that clenched when you saw DynamoDB, calm down, because what this really means is that this is going to be a serverless solution, or serverless database solution. Right? I would love to find out a way if we can host Quirk data and do Mark II in a serverless database solution. If we could do that, that would be awesome. Okay? So again, I'm not saying that this is anything particularly yet. I'm simply just saying that a serverless solution would be great here. The reason why we need this database is because at the end of the day, right? We're going to need data. Like we're going to need like user data, right? And so this is actually technically going to be Twitch event sub and user data, right? That's technically the data we have to pull from here is Twitch event sub and user data. And so this needs to come from a database on some level, right? Oh, give me links, by the way. Give me links, by the way. So we had AWS cloud events. Somebody recommended serverless, right? The MongoDB serverless. This is the link, right? What other links? Yeah, these are for experience. Yeah. Well, it's a bit like the let me put it to you this way. These suggested texts or suggestions, I guess, as I would say, these are for experimental, right? But what we choose is like, that's what we're going to use. You know what I mean? Again, I want to be clear. Let me rephrase this. Serverless DB, right? I don't want the moment we put anything in here that has to run 24/7, I don't want to talk about it because I'm just going to run RDS. like I'm serious. I'm just going to run RDS because it'll be in my VPC. It'll be easily usable. The only thing that I'm super interested in is serverless database solutions because I want to pay. So like, goal is to pay by transaction and data, not by CPU time, right? That's the goal here, is to pay by data transaction and all of that stuff, not by CPU time, right? So AWS DynamoDB is another one. No, I don't think so. I think those wouldn't be. I mean, Dynamo is one of them. S3 buckets solved. No, I mean, it needs to be while providing we'll say high throughput, right? Like we want it to be performant, you know what I mean? High performance is what we should say, right? And apparently DynamoDB is one of those ones that it's supposed to be able to be highly performant. I don't know. I've heard a lot of bad stories about DynamoDB, okay? So that's the only reason why I really want to try it, is because I've heard so many bad stories and I'm slightly curious about how bad they really are. Right. Yeah, exactly. Yeah. So again, that's why this is a bit of an experiment. So does anyone have, was CosmoDB? That's Azure, right? And is CosmoDB also serverless? CosmoDB. Gotcha. Oh, well, no, I don't want to. No. No, we're good. All right. Everybody in chat just went, it is expensive AF. All right. Never mind. Guess what? We're not using CosmoDB. I'm not gonna try that. So is there anything else besides DynamoDB and what is serverless application development? Oh, no, but this is, wait. Okay, so hold on. Is Atlas a 360 CPU solution? Answer me yes or no right now. Is Atlas the same as DynamoDB or not? No, it is not. Okay, so it's a normal database. Okay. All right, absolutely. Okay. All right. It has serverless. Okay, okay, but what does that mean? Well, I see. So you get it through the pricing, but it's still based on number of records. Okay, I mean, do we want to say that that's similar? Do we want to say that that's similar? That's about as transactional as you get? Yeah, I guess that's fair. Serverless. Okay. I see. Okay. Okay, so I've got Mongo in here. Actually, here, let me just do this. Because the pricing one was a better, like, direct me to it thing. Okay, so we've got Mongo. What other ones were we saying? Was there a Neon Tech? Serverless Postgres. Interesting. Planet scale. I'm just investigating everything. Like, we're going to try Dynamo first, obviously. I'm just looking at, like, pricing comparisons and stuff like that. Like, this would be... See, here's the thing, though. No. Nope. Out. Do you know why? This isn't what we want. This is not what we want. We don't want monthly. So, no. Planet scale's out. It's out simply because we don't want monthly. We want to literally pay just for what we're paying for. That's it. What about this one? You guys are making me look at the pricing and shit. Monthly is the same as CPU hour. Yeah, it would be. Monthly would be the same as CPU per hour, yeah. If I do 5 records 1 month, I just want to pay for 5 records. That's it. Like, that's what we're trying to investigate here. Also, where the do I find the information I want to hear? I don't want to sign up. Like, where's like contact sales? Dude, is this even a thing, or did you just like send me something with a generous free tier? Technical preview free tier. Oh, dude, this isn't technical preview, buddy. I can't do this. I'll keep it like as a tab, but I can't do something that's in technical preview. Yeah. Look up Cockroach. Honestly, you know what's good about Cockroach? We know somebody who works at Cockroach DB. We might be able to get a hookup. I'm just saying. Shout out to Large Data. What's his name? Data, whatever. I can't think of the third part of it. Solutions. No. Product. Elastic Scale. Large Data Bank. Thank you. Yes. I don't know why. I wanted to say database because he works with database. Oh, come on, bro. Just give me freaking prices. Pricing. Okay, here we go. Serverless. Start for free. Yeah, this is what we're looking. See, this is what we're looking for right here. Dedicated. Oh, no. But then 1 gigabyte for additional storage. So wait, what? I'm confused. Their only serverless one is forever free of 5 gigs, and then for every additional gig and additional request units, you pay additional $1 for 10 million. Oh. Interesting. Yeah, I mean, that makes it an option. I don't know how viable it is, but it does make it an option. The magical unit. Yeah, the magical cloud units. Yeah, I mean, that makes it an option. All right, we went down a bit of a tangent here, chat. Let's focus back up. All right, so we'll look at some of these. We said that Neon couldn't do it because they're still in alpha, but it looks like both Cockroach and Mongo and DynamoDB could do it. Again, we said that Azure Cosmos could, but like it's ridiculously expensive, right? That's basically what we made the decision on that Cosmos. So Cosmos is Amazon's competitor to cloud hosted SQL. It's just ridiculously expensive, right? That's what I'm getting. Hang on one second, chat. Sorry, work stuff. So now you outbound data channel both. Yeah. Okay. All right. So, so let's go back to our design here a bit, and let's keep working through it. Okay. So we got to the point where whatever this thing is here, right? Again, whether it's a WebSocket, whether it's HTTP request endpoint, like whatever it is, whatever we decide to make this be, right? It's going to talk to some serverless database solution. Hopefully, we'll see if we can make it work. Might be an option if you like Postgres. It's not really serverless, but closer than regular Postgres cluster. Oh, okay. I appreciate it. That's TypeScript tea time. How's it going, by the way? Azure, they keep talking. They make Cosmos shoot. However, they're still really expensive. Okay. Well, here, you know what? Just for gits and shiggles, man. Because here's the thing. Azure Cosmos DB. The only reason why I'm adding it is just because we're really small scale right now. So unless you guys are saying that like even at like our tiny scale it would be bad, it just might be worth just looking at it. Just looking. Like we'll probably do this one day, So this will probably be like a whole day of just like doing that. So yeah, okay. So once that message gets here and we get the data that we need, right? I know. Yeah, no, Jonah, you're not wrong. You're not wrong. We get to here. Now, we've said that Amazon EventBridge would probably be the best solution here. I would never use it again. Oh, Jesus. Okay. Amazon EventBridge would probably be the best solution here. If you guys don't know what AWS EventBridge is, right? The idea essentially is it's an event bus. Here, do you guys want me to here? Let's watch the YouTube video on it, chat. Wait, no, that's not the video I watched. All right, you guys want to watch the YouTube video on it? We'll watch a little bit on it.
Hello, and welcome to Serverless 101. My name is Eric Johnson, and I'm a principal developer advocate.
Oh shit, his name's Eric too.
At AWS.
Nice.
Serverless 101 is a video series to help you get acquainted with the AWS services that are serverless. In this video, I cover Amazon EventBridge. We'll talk about what it does
use tab 9, yeah.
and when you should use it. Let's get started. Amazon EventBridge is a serverless event bus that makes it easier to build event-driven applications at scale using events generated from your applications, integrated software as a service or SaaS applications, and AWS services. Phew, that's a bit of a mouthful. Let's take some time to unpack
I love his
this.
enthusiasm.
First of all,
about, like,
let's
serverless.
make sure we all agree on what an event is. An event is a record of an action that has happened in the past. In this context, it is represented as a JSON object that contains data from the event and metadata about the event.
So I want to pause really quickly, right? One thing that I think is something to note here that is really important is that we are staying consistent with the idea of what this naturally is, which is Twitch has an event sub and we have an event sub, right? We're keeping the paradigm that Twitch has created of like, we're messaging and we're sending events and we're responding to those events. So this is another thing and another reason why I really like taking this approach, because we're still subscribing to the same paradigms that Twitch is for their implementation, meaning it should be easier to work with, right?
For example, if someone saves a file to Amazon S3, an event is created containing the bucket the file was saved to and the key or name of the file. It will also contain data about when it was saved, the size of the file, and other metadata that helps developers to understand the event. Another example would be someone pushing an IoT button. The event will contain information like when the button was clicked, the type of click, single, double, or long click, and maybe the location of the button. Events can come from many different sources and can look very different from each other. Okay, second, Let's define an event bus.
What's up, Cat?
An event bus can ingest many different events from many different locations.
This is what I wanted to show you guys.
As the events enter the bus, they remain on the bus for a configured period of time. These events can come from external SaaS services like Salesforce or Zendesk. They can come from internal AWS services like Amazon S3 or AWS CloudWatch. Or they can come from custom applications that you are building. Okay, you might be asking, now that we have all these events on the bus, how can we use them? Amazon EventBridge allows you to set up rules. These rules are data patterns that match some or all of the events on a bus. EventBridge evaluates each event against each rule you create. If the rule does not apply, the event is ignored by that rule. If the rule does apply, then EventBridge will send a copy of that event to a configured target. Either way, the event remains on the bus to be evaluated by other rules. Using EventBridge, data can be sent to any number of targets. For example, a common pattern is to invoke an AWS step function workflow. When a rule targeting a step function workflow matches an event in the EventBridge bus, the workflow is invoked directly by the EventBridge service, and the event is passed in as the input. Using this pattern, developers can build asynchronous event-driven applications using real-time data. Developers are also able to decouple their applications to increase application reliability. So let me explain that. When designing applications, even using serverless, developers can often make the mistake of tightly coupling their applications. For example, I have two Lambda functions.
This is what we were talking about earlier,
and the other handles subscriptions. It would be very easy for my application to first take the payment using the first Lambda function, then the first Lambda function calls the second Lambda function to create the subscription.
Like literally what we were talking about.
By doing it this way, I have tightly coupled this portion of my application. If my subscription fails, then there's a chance the payment process might get messed up as well. This causes my application to be brittle. A better option is for the payment service to drop a request on the EventBridge bus requesting a subscription to be created. If the subscription Lambda function fails or is unavailable, the payment Lambda function can still go about its business. This brings about another feature of Amazon EventBridge. If a target service fails, EventBridge can be configured to retry after a certain period of time. If the process still continues to fail, the event can be dropped into a dead letter queue for troubleshooting as needed. If you have already watched the Serverless 101 series installment for Amazon SQS, you might be asking, how does this differ from SQS? Actually, quite a bit. SQS is designed to ingest many events as well. However, they are generally processed in a batch and are removed from the queue after the event is successfully processed. EventBridge events, on the other hand, are handled one at a time and can match multiple rules and be delivered to multiple targets in their lifetime on the bus. Okay, here's one more fun fact. If you have an AWS account now, then you already have an EventBridge bus working for you. Every AWS account has a default bus that can be used to pass event data from AWS services. You can use the default bus for your custom events or create a separate custom bus to isolate incoming events.
Hang on. One thing to note about that custom event bus, that nice event bus that they give you, chat, is that they also integrate all of their services into it as well. That's one thing to note is that default event bus that they so nicely give you is also there to integrate all of their other services that use event buses and stuff like that. Yeah, no, I'm aware of it. Yeah. So you probably don't want to use the default event bus. Otherwise, you're going to get a lot of events that you don't need.
One final thought on EventBridge before we go. In addition to collecting events and distributing them to targets based on your rules, EventBridge also has a schema registry that collects and stores event patterns. This is helpful as a developer to understand what service events, SaaS events, or even your own custom events look like. This has been a high-level overview of Amazon EventBridge. I encourage you to dig into the individual features of EventBridge to make it work well for you. For more information about Amazon EventBridge and other videos.
Cool. So that's EventBridge. And again, that was something, EventBridge was formerly called Amazon CloudWatch Events. new features were added. Oh yeah, no, we don't have to worry about that. But yeah, that's basically what I wanted to show you guys. Is the idea is that when the Twitch API gets generates an event, and that gets sent to, again, whether it be the WebSocket or whatever, right? We go out and grab some data from our serverless database solution to get information about that event, right? Just like he said, he's like, when you get an event, you get some type of metadata, right? Well, Twitch has their own event sub, and then we have our own event sub, right? And so what we do is we take the information from theirs, process it, and then dispatch it to our event sub for handling our stuff. Right now, one of the things that is really nice that he mentioned that like we technically could do if we wanted to is we could technically use step functions in some places, right? So for example, right now we have a Lambda function that just does the preview by itself, and then we like send a message back through. However, if we really wanted to, we could make a step function that is specific for the stream online event, right? And then that step function, so like that step function would basically be our lambdas, right? And so the idea here would be like the step function would basically fire, one after another, and then EventBridge would talk directly to that step function, right? And that's something we could do as well. It really depends on like our, a big word here, which is our coupling, right? How much coupling do we want to have between these things, right? And for example, if we want to couple everything related to sending out a message to a specific thing, then we could do that. But we really still want to think about our use cases, right? We send a lot of Discord messages, so it's really going to be helpful for us to have a Lambda that can just do that. Right, same thing for Twitter messages. The same, Lambda can just do that, right? Twitch preview, right, just do that. So I would say the step function thing, if we do use it, we might use it a little bit more, scarcely. But I really like this overall solution. So before I go forward, right, let's kind of look at our document one more time and let's break down, right, like what we've got here, what we built, what the document we created today, right? So we created a document that says that we want to solve the problem of go live and offline notifications, right? The problem is that we have no way to provide notifications to integrations that exist within Quirk, right? What exists currently, there's Twitch Event Sub, which we can integrate with Event Sub using two different types of connections, WebSockets or webhooks. The pros and cons, we broke down of both of them. The pros of webhooks is that they're stateful, right? That they, handle through an HTTP request. So we have like error handling and stuff like that. And it's easily scalable, right? Because it's request driven, more requests, we just scale them more. The cons were that the biggest con I think here was just that it needs to be a public service, right? This is a scenario where we have to make something public that is accessible online all the time. Although the WebSocket needs to be online all the time as well. Right. The main point here is that this needs to be public. This needs public infrastructure with like, once you go public, like there's so many things to talk about. You've got ingress, right? And actually before you've got ingress, you've got WAF, right? You've got ingress, you've got routing, right? There's a lot of stuff that needs to be set up here to make sure that basically your request from Twitch, right? Twitch to WAF to ingress, to specific routing, right? Like this is all part of being a public service. So it's not just like, hey, I can put it online, it's definitely being like, okay, there's multiple steps that still need to be done here. And this is a bit of a con, right? So what did we do? We naturally made it integrate into our main API in Quirk Mark 1, right? However, I didn't like that. Should we do Quirk.Mark1 or Quirk.Mark1? I don't know. Something like that. I don't know. But, whenever we made changes to the API, then it would also affect that, which meant there could have been downtime, bunch of other stuff. Actually, here, we'll just do Quirk Mark 1. There was downtime and stuff like that. And we didn't, that bugged me. So I really, whatever we do, whether it be webhooks or WebSockets, like this needs to be its own service with its own, its own managed deployment cycle and all that kind of stuff. We really don't want it to necessarily have to be a part of any other deployment or any other changes or anything like that. So the WebSockets were our next approach, right? Pros of this was it doesn't require public service, so that's the immediate, antithesis to the con in webhooks, right? Doesn't have to be public, right? This can just be a service running anywhere, right? And as long as it can, that it can talk to our event bus, we're good. The other thing that's really nice about it is it's low latency, right? Because we make a persistent connection to Twitch, there's no need of like processing through routes or routing or anything like that. Like even in the sense of like something might have to process through a web application firewall, it doesn't have to here because you've made that direct connection already. There's no layering between the persisted connection. It's just, you're there. Like you've already routed through everything you needed to. It's open, The downside to WebSockets is it's not easily scalable, right? Dealing with things like deduplication, those could be challenges. Stateless, we don't know if we got messages or not, right? Because we only really know if we're connected or not. And the connectivity, although again, we said that this is still pretty important to both, is that we need to make sure that it's, it's online all the time. Basically, if it's not online, then, we are not getting any messages. And as a matter of fact, we can just say uptime, since that's another big thing, is we do not receive any messages when services are down for ingress of Twitch sub or Twitch event sub events, right? And that's like another thing to kind of note here is like uptime needs to be all the time for both of these services. It's such an event-driven service that if we don't have it up, we're just missing things, right? And again, that's for both WebSockets and webhooks. Both of them, they just need to be up. They need to be up so that we're getting messages, because if we miss one message, it could be a go live notification. It could be something that's really important. So uptime is a massive part of this. The other part is WebSocket. Let's go back to WebSockets, my bad. So again, not easily scalable, and then stateless because we don't know, right, when we got messages or not. Another part of this whole process is going to be reconciliation. So event sub, right? Event sub requires many subscriptions or one per event basically. So go live notification, a go offline notification, a follow notification, all of these things require subscriptions to specific events for us to be able to actually get them, right? And so we have to be able to reconcile and make sure that those are always there, right? And what that means is that, when they're individually subscribed, we have to check Twitch regularly for missing subscriptions. And then when missing, we trigger a subscription again, basically we go back to here, right? So there's also this reconciliation process where every 5 minutes, maybe we go out to Twitch, we make sure we've got all of our stuff. If we don't, right? There's that. Now, here's the thing that's interesting about that we haven't talked about, which is this problem. So let's investigate this problem really quickly in the previous one here, right? So we know what this is going to be, so we can just delete all this. Let's go back to this one here, because this might actually help us solve if we'd rather do webhooks or if we'd rather do RESTful endpoint, okay? So we just said that reconciliation is required, right? Reconciliation is something that's required. So if reconciliation is required, that means that we're going to need an additional service, right? Some other service that does like a cron, basically, right? This cron is going to be what's in charge of reconciling or polling to make sure that we've got everything we need. Now, in this scenario, what happens is, in this scenario at least, what happens is the cron goes out to the Twitch API, right, in the first scenario, and then it says, all right, well, if you're missing anything, right, resubscribe to it. And what that does is, this is just a one-way, it goes out and then it resubscribes. It goes out, then it resubscribes, right? What that means is that this is a one-way data flow. And if you don't understand, don't worry, we'll make it make sense in a second. But in this scenario, all we really need, if we go back here, is a database to tie these two together, right? So we have some type of serverless database solution where in this, or database in general, where what happens is each service goes out and speaks to the database to see information. And so this one will go out to the database to see what we've already subscribed, right? And then update it. However, this is where stuff gets a little bit more challenging. So let's go to Twitch API event sub. And then let's look at WebSocket. Because I think it actually might be more complicated. Yeah. So when a WebSocket is created, a ID is returned to you from WebSockets. At that point, the application, has to go out to the API. So what that means is that this actually goes back out to the API like this, outside of the additional connection, or outside of the initial WebSocket connection. And this is a REST request, post request, right? So this is a post request that actually tells it, hey, I want to create a subscription. So we can say, actually, to make this a little bit better, this is a create subscription request, right? And this has to be done for each event, just like it has to be done here, right? Create subscription request. So what's going to happen? Oh, that's interesting. Interesting. So in this scenario, chat, what actually happens is the event sub has to talk to... Yeah, it actually has to talk to this. So this is the difference. And it also has to go out. That's interesting. Does that make sense? Do you understand why this is different here? So basically what happens is this is a lookup for subscriptions, right? To see what we currently have. We have to look up for the subscriptions. And actually here we can do both. And so this is, first we look up for subscriptions, right? And then after we do that, we go out and we say like, okay, what's in the database that we know is already subscribed, right? Because that's what this does. The public API tells the database when things are subscribed, right? And then basically, if there are any missing, then the cron goes out to Twitch and says, hey, register a new webhook at this place. And then what happens is this becomes like a full circle, right? The cron goes out to Twitch, Twitch goes out to us, goes into the database. Done, 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 done. And this is our reconciliation loop. This is the loop that we've created. In this scenario, however, what happens is the initial connection is made via WebSocket, right? Once that is created, it gets an ID that this service has to go out to the Twitch API directly and create its subscription request with. This service is what actually creates the subscription requests here. So if this service is what creates the subscription requests, then that means that this service also needs to be able to create them when they're missing, right? Now, we want the cron process to be separate. There's a bit of an argument here to say that we could do the reconciliation logic within this service, this backend service, right? We could say like backend WS, backend API, just so that we know there's a bit of a difference. I don't know how much I love that though, because if it's something outside of this, it's easier to manage. So I would rather keep it outside of this. So if it's outside of it, this one connects to the thing. All right, actually, hold on. We need to make this a little bit different. Hold on. So this needs to go like this. So what's going to happen technically is this is going to go out to here because it's going to need to look in the database just like it does in the top one, right? And that's when an event happens. So if there's nothing to subscribe, this does nothing, right? So that's basically the point is that if this service starts and we have nothing in the database for it to create subscriptions for, then it has no requests to create and then it just dies, right? The socket's killed. So what has to happen is at some point we have to, interesting. Oh, this might actually be easier. No. Subscription limits. Okay, here we go. The following limit is for you can create a maximum of 3 WebSocket connections with enabled subscriptions. Reconnecting using a reconnection URL doesn't add to your socket. Each WebSocket connection may create up to 100 enabled subscriptions. Oh. Okay, we're not using WebSockets. Yeah, we're not using WebSockets. It's not meant for scale. WebSockets are not meant for scale. Well, that was a quick end to that. Yeah, there's no way. We would already go past 100 subscriptions with one WebSocket connection. I'm not even kidding. We already have 100. So I'd have to create 2 WebSocket. Oh, wow. Yeah, no. No, we're not doing it. All right, so here's going to be our massive limitation to WebSockets is limited to 100 subscriptions per connection. Each user currently has 33 subscriptions. So 3 users and we're already at our limit. Yeah, that's not gonna work. That's not gonna work at all. It's gonna have to be. Yeah, we're gonna have to do the webhook approach. Yeah, I'm not dealing with that. Honestly, that's too much. Here's the thing that's tough about that too, dude. Real talk is look at how many subscriptions you have. Are you meaning to tell me as a service, like, look at all these subscriptions, dude? We don't even have all of the new ones. Like, this is 1 per user. These are all the subscriptions per user. Yeah. Subscription per event type per user. Yes. Yeah. Yo, Nintron, thank you so much for the Prime, man. I appreciate that. Thank you for those Bezos Buckies, my friend. How are you? Hello. There it is. Hello. There we go. I got it. Hello. There we go. Yeah, dude. No, there's no way. You'd basically, you know what you'd have to do, chat? You'd basically have to create a WebSocket connection per user. Yeah. That would be the easiest way to scale it. And even then, what happens when you get past 100? So that still doesn't work. That only has a limit, right? Because what happens when you get past 100? The limit is probably there to, yeah, I don't disagree. Yeah. I mean, again, dude, Jono, anyone else who's been here, right? We talked about this. Hands down, WebSockets are hard to scale, right? So maybe this is Twitch making their stand on it and just being like, yeah, we're not letting you do it. But we can't. So yeah, so there's no way to do it. There's no way to reliably, listen, I think every single person in this chat can agree with it, that if I am making you a product that you want to use and rely on, you would want me to make the best decision, whether it be a little bit more challenging or not, to, host it, but the one that has the true more long-term solution. the WebSocket thing wasn't that bad until we saw the limitation right there. That limitation was the nail in the coffin for WebSockets. Yeah, once I saw that, I'm like, no, there's no way, dude. There's no way. Look at all of these. Like, again, there's so many. Look, and they've got in beta, for God's sakes, man. Like, you know, and we want to like, that's the thing, is we want to get to a point where we could just add these to the event sub and then just start processing them. You know what I mean? So yeah, no, I don't feel like fiddling around with like WebSocket limitations and stuff. No, you should create one connection until you have a reason to create another. For limits on the number of connections you can make on subscriptions. Yeah, see, if you send a message to the server except upon the server closes the WebSocket and connection lost, you need to resubscribe to the events after connecting to the server. Oh my, yeah, dude, no, dude, that means every time this thing dies, you're going out and you're making like a shite ton of requests to Twitch before it can start back up. This is terrible. Oh, wow. Okay. So here's another thing. Here we go. Here's another con. Slow startup. Requires all subscriptions for every user to be set up on restart. Yeah, the more we look into this, the more this sounds like a pain. Right? Like, all of the webhook stuff is just technical, right? Even though it's a public service, like, it's still pretty technical. Oh man. And so yeah, so in this case, what would have to happen is we'd have to make it so that the service, so this is how it would have to work, chat. This is how it would work if we did it with WebSockets and a cron. Yeah. Oof. Right. And considering, yeah. So yeah, look at this one. This one's crazy. Look at this. So in this scenario, in the WebSocket scenario, we do our initial connection here. Once we do that initial connection, we go out to our serverless database solution and we get all the subscriptions we want to create, right? So basically we go out to our database and we say, all right, which users are connected to Twitch, right? After we do that, we create 33 subscription requests for each user. And then get responses back from those from the WebSocket. Once we get those, we are starting to listen and we can start processing stuff. If this fails for any reason whatsoever, the whole process has to be done again. So if this were to fail in a sequence of fail, restart, every time it's going to go out and do hundreds, if not thousands of requests to Twitch, which might also make Twitch DDoS itself. Or make Twitch like indirectly DDoS Twitch, which could then give you rate limits on API issues, right? And we haven't even talked about reconciliation yet. Reconciliation involves the cron going out to Twitch, looking up subscriptions, right? But it can't just go out to Twitch and say, hey, I want to create a subscription. Oh, you know what? No, it can. It can. Yeah, it can. So technically it could. Yeah. No, my bad. It technically could, yeah. It would just do the same request. Or if we wanted to make it so that this only does that, then we could decouple it. You know what I'm saying, chat? Like if we wanted it to, we could say, all right, well, instead of you doing that, we'll always say that the create subscription logic is here. And then we just make an endpoint to say, request subscription, right? And then this endpoint is where the logic is handled so that then it could be like that, right? Oh, man. There's a lot. Yeah, the WebSocket approach seems a bit rough, man. That's fair. You can actually use Lambda and API gateway for sockets. Lambda and API. Oh, yeah. I know what you're talking about. Yeah. I evaluated API Gateway. I've heard not great things about it. Yeah. I've heard that API Gateway kind of sucks. I don't know if I want to use it. That's just me being real. I looked at it. I'm not. You got to believe when I say I look at pretty much most of the solutions you guys have suggested that are at least on like the Amazon platform. Is it? But yeah, no, I feel you. I feel you. There we go. So yeah, this is a little bit more complex than the circle we have here. And again, we don't get the scalability here, dude. We just don't. Having to create new WebSockets. Like, okay, so where's was it Othugmuffin, I think it was? Or no, Woof Woof. Woof Woof. Woof Woof was talking about, hey, being worried about opening ports for WebSocket connections, right? Yeah, in this scenario, yeah, absolutely. If I have to create a new WebSocket for every user, then yeah, that's going to be a problem. At some point, I'd like to have 65,000 users. So yeah, like no, that's where like, you know, this really does become a problem. And yeah, you would absolutely have to be worried about like ports and stuff like that at that point, because you'd just be opening a gratuitous amount of WebSocket connections. I just don't think it's needed. I really don't. So I think now that we have a better idea of this, let's go back to our initial design, right? Let's delete this. Let's delete this, right? And then let's add what we're going to do now. Actually, I guess I didn't need to delete that. Yeah. So this actually will now be a API, right? This will just be an API endpoint of some regards. And then the Twitch API is going to be one-way directional now, right? Not both. Other way. One-way directional, right? And then this will actually need an ALB in front of it. Or what? Load balancer. Now this wouldn't be in the EKS cluster, but it would be in our VPC. So there we go. Let's move all of you over a bit. Move that. Oh man. Hold on, chat. I gotta fix this. No. I'm just moving everything in one direction. I'm not actually doing anything. Oh. There we go. That's what I really wanted to do. Okay. So then that goes to that. Oh, and this can be red, I guess. Or whatever color this is. I have no idea what color I picked and why it's not the same as the other ones, but okay. 6. There we go. Yeah, there we go. And so the only other thing that we're missing here is we're missing the cron job. The cron job's not in this design. Which if we wanted to add it, we could. We just have to move this over a bit. Take this, move this over a bit. Take all of this, move you over. I don't know the best way of doing this. So the event sub, here, let's move all this over here. And I think what might be best, move this out. Let's just disconnect this for right now. I think maybe above it might be the best play, yeah. So we're going to need 2 services, technically, to solve this problem. Cron. And so the cron goes directly out to Twitch. Let's do this. Go here. Sorry guys, just bear with me. Like this. Like this. And then so what's going to happen next is we do go to our database solution. This can all go over. Yeah, and so the cron is going to go out to the database to check it. And then so is event sub. Yeah. Yeah. And that's it. So if we look at this at a larger scale, right? Basically what happens is whenever, interesting. So basically what happens is Twitch API sends a message to our load balancer, right? Our load balancer then sends that to the API service to handle that, specific request. Once the API service gets that request, it immediately drops it off to EventBridge for the event that triggered, and then that triggers the specific, lambdas that are listening for that rule, right? If we're talking about reconciliation, then what happens is every 5 minutes, whatever, something like that, a cron triggers, and that cron does two things. It first goes out to our database to get everything that's currently subscribed from our perspective that we know about, right? Because we may not be accurate. That's why we have the reconciliation. And then we go out to Twitch and we do the same thing. And then we compare them. And once we compare them, we go back out to Twitch and we say, hey, Twitch, there's some other subscriptions here that you're missing. Please resubscribe them for us, right? And then once that happens, it goes back through the process. Now, there is something else that we're not fully including here, which is like how and when does a user, like when they connect their account, I guess like where does the subscription logic happen? Because right now, this goes out to, lookup / create subscriptions, right? We create a subscription here, right? And then we listen to subscriptions here. But there's also a scenario where we have to do the initial subscription setup. And so maybe this is a scenario where when a user, like, I guess what I mean to say is like, how often does this cron run? Because how often this cron runs could depend on how we implement this. When a user connects their account to Twitch, right now, what we do is we do everything right as they connect it. So they connect and they basically wait until everything is done. So it's like this really long, like synchronous process. However, there is a scenario that we could say where when a user makes a connection to Quirk, right? What actually happens is we just save that in the database, right? And so that the next time the cron does its reconciliation, then we get messages. So basically we could say like, all right, when somebody signs up for a Twitch connection, we say like, it may take up to 5 minutes before you get your messages, right? And so like, once we do that, or what we can do, and this is where, it also gets a little interesting, is we can lean back on this and we can say, all right, well, here's another thought. What if we make a subscription thing, right? Or a subscription lambda. And we say like, okay, we also have a event subscribe lambda, right? And so this lambda is now designed to handle the scenario whenever we need to go out to Twitch, right? Because again, we are kind of wanting to make sure we're considering the reusability and like these units that we want to reuse, right? And so if we do that, if we're like, okay, let's do that, then we can tie this into event sub, and then we can say that this is an event that happens, right? Maybe this is maybe there's a like expired event or something like that. So I'm going to get rid of this for right now just because it's in the way of what I want to show you. But basically what we could do is we could say, all right, well, when we look up here, when we use the cron, we just look up here, right? When we want to actually create subscriptions, we say that this is an event that's in EventBridge, right? And maybe it's like subscription expired or something like that. I don't know. But when that happens, then it fires the Lambda, right? Oops. Yeah, let's do that. And so what happens now is the cron goes out to look up subscription. It goes to the database to look up subscriptions, right? It goes to Twitch to look up subscriptions. And then once it's done that, we say, okay, here's ones that have expired. Right, and so this is event sub dot expired, right? Maybe like it's an expired subscription or something like that. And so when this event goes to EventBridge, that is when we go down here, and this, instead of being the Twitter API, is the Twitch API. Exactly, yeah, we do need our own record of some sort. That I kind of like. The reason why I like that as well, right, is then what we could also do if we wanted to kind of expound upon this a little bit more is we could say like, okay, well, what about with user signups and stuff like that? Like how exactly would that work? Well, remember the EventBridge is the main source of truth for like everything. Right, so not only does the Twitch event sub cron, you know, have the ability to do it, but what we could also do is we could say, all right, well now we're going to create a dashboard BFF, right? And this, if you guys don't know what a BFF is, that's a backend API, basically that's for front ends, right? So this was another problem we had where we said like we don't want our API that serves and supports our front end to be related to the API that serves and supports Twitch, right? We want those to be in separate places and managed by separate things. And so what we can do is we can say, okay, we'll tell you what, here's what we're going to do. We're going to take this load balancer. We're going to give ourselves a little bit more room, right? And then we're going to say, all right, well, not only is Twitch API now going to go to traffic, go to the load balancer, but also a client, right? A user, like the front end. This is a user going to the front end, right? So this is dashboard user, right? And so this dashboard user is now also going to go to the load balancer and make requests, you know, for whatever they're trying to do. So in this scenario, the dashboard user goes out to the load balancer just like the other, you know, just like Twitch API does, right? And then what happens is they get routed here, right? They get routed to the API because, or the BFF basically, because that is where their routes go for handling, you know, front end requests, right? Now what we can do is we can say, all right, well, when the user connects, we can have another event in event sub. So we'll make one more event now. And this event can be here, we'll make this actually that. And this can be event sub like setup, right? Or something like that, right? Or you know, they can both be event sub setup or something like that or whatever. But basically when this happens, then we say like, okay, when we have an event sub setup, right? then we fire the event subscribe. Right? So we have this really, really nice reusability now within our microservice or within our application, where we just send things that we want individually processed to EventBridge as events. And this is kind of the glue between what a lot of these things do. And it's actually really nice too. Like if you look at it, right, we don't have any really weird traceways. Like none of these paths are like, you know, overly complicated or confusing. You know what I mean? Like the TLDR is that Twitch API goes to a load balancer, which goes to goes to our API, and we'll call this backend API. And actually, if we wanted to, we could say this could technically be a backend for front end, but it's for the Twitch API. But whatever, it's fine. But yeah, basically, a Twitch API goes to our load balancer. The load balancer proxies or sends the request to the backend service, and then that backend service sends the message to EventBridge, right? Which then handles all of our sweet Lambda, queuing and all of that stuff. There we go. Or, right? Sorry, I'm just trying to give this a little bit nicer look here. There we go. Or if we need the cron to do, its job, the cron goes out to the Twitch API and looks up subscription. It goes into the database and looks up subscriptions. And then whenever there are ones that aren't there, what do? We go right out to EventBridge and we say, hey, there's some event subs that have expired. And these ones that have expired now get handled by event sub subscribe. Just like the event sub setup event that happens and it handles event sub subscribe. I really like this. Yeah, I'm super happy with this, honestly. I think, how do you guys feel? What do you think? Do you guys think that this will be a really, really, really nice thing for Quark? I think so. I really like this solution. I think it's going to be leaps and bounds better than what we've already got. That's for sure. Now, technically, what we have shown here, chat, right, is a few things. We have messages coming in through Twitch and how we're going to process them, right? We've solved that. We know that the Twitch here, let's design a few flows here so that these can kind of make more sense from a color perspective. So we'll make this one blue. We'll say that when Twitch reaches out to us, here, we'll put this like this, separate these a little bit more. When Twitch reaches out to us, we follow the blue path. Twitch reaches out to us, that goes out to Event Sub Backend API, and that goes to EventBridge. And that can go to any one of these, right? So that's the thing to kind of note here is any one of these can be fired, right? Then we have another path, which is this one. Right? And that's basically the setup for reconciliation. This is the reconciliation path, I guess we can call it. Make it purple. Yeah. So this is the so purple's reconciliation, right? Blue is receiving and processing events. And then we'll make this one setting up. Right? And then again, all of this goes to this. So they'll all go to one of these or whatever. I just joined. Yeah, so I'm going to be real with you. I'm actually getting close to wrapping up for the day. But let me try and break it down for anyone who's here. So, all right, if you're just tuning in, let me break down for you. We are rewriting the platform that we have been building for a while now, Quark. We are going to be creating the Mark II version of Quark. So the things that you see in chat, from our messages to the lights changing, all of that, that's the Quark platform that we've been building for quite some time now. And as a matter of fact, this is Quark right here. In the VOD, which I highly recommend you guys check out the YouTube, subscribe to both the main YouTube as well as the archives. I do have a Knicks video coming out very soon. I wanted to get it out this week, but I couldn't, unfortunately, because there was a lot of stuff last week with work and this weekend that kind of took all my time. That's why I wasn't streaming the first part of this week as well. But do subscribe to the YouTube. The main YouTube, again, is where all of our curated content is going to go and all of that stuff. And I do hope to get the video out next week, as well as the VODs. All of our VODs are on the archive. So if you ever want to like go back to a previous VOD, see anything, check out the VODs. But basically in the VOD, you'll be able to see me break down Quirk, what it does, kind of like all of its stuff. And, I talk a bit about like where it was, kind of where we brought it, how I integrate it with build configs, which was the Rust CLI tool we were building. And then we got to the point where I was like, all right, we're going to rebuild Quirk from the ground up. It's time to build Quirk, Mark II. And so what Mark II looks like for us is looking at Quirk's biggest features and building really good systems around that. And Quirk's, if not biggest, most important feature is its go live and go offline notifications, right? So when Twitch, right? So Twitch, go live and go offline notifications, right? And the problem is that we have no way to provide, again, we're starting from scratch. It's a brand new, Mark II version of it. So we're going to, we have no way of providing solutions to, integrations that exist in Quirk from Twitch, right? So what exists, we talk about Twitch Event Sub. We talk about how we can integrate with either webhooks or WebSockets in Twitch Event Sub. And then we broke them down, right? We compared the two, and we spent a good amount of time, right, just figuring out the differences between webhooks and WebSockets. The biggest con for a while was really, that webhooks require you to have a public service, right? Whereas WebSockets don't require a public service. WebSockets could also provide a bit more speed and stuff like that. But when we talk about scaling, that's when webhooks really come into play because they're, stateful, they're easily scalable with requests and all that stuff. Then we hit the really big problem, which is apparently Twitch has a hard cap on how many subscriptions you can do per WebSocket connection. And that is 100 subscriptions. So even if we wanted to be able to scale based off of our own parameters, we can't with Twitch's WebSocket implementation because they flat out say, no, if you go beyond 100 subscriptions per connection, we kick you. Now, each user has 33 subscriptions currently, and we're going to be adding more soon. So this does not have any ability of scaling whatsoever, right? Now, again, WebSockets was actually in the run for a while. Most of you guys voted on it. So we did really think that WebSockets was going to be something really powerful, but then we kind of realized that, this was going to be a problem for scaling. The other problem was that it was slow startup. It required all subscriptions for every user to be reset up or subscribed to on restart, and that was another big problem as well. And so that's when we realized, webhooks is the way to go, and I think everybody here can agree on that. I really do. I think we were back and forth. We were doing a really good technical discussion. And I think we got to a point where we really felt like, yeah, this is really what we should be using. So we decided to use webhooks, which is awesome. And we talked a bit about the reconciliation. We said no matter what, if we use WebSockets or webhooks, there's going to be a process that's involved where we have to go out to Twitch and our database and compare the two and be like, okay, what is subscribed and what isn't? And then if there is anything that isn't subscribed, we need to make sure it is subscribed so we get those events. You know what I mean? And so this reconciliation process is something else that we talked about. And then uptime, right? Uptime is a crucial part of it where we do not receive any messages when services are down, right? Whether it be for, a WebSocket or for a, load balancer request. We need to make sure that uptime is crucial, right? Crucial. It's uptime crucial. We talked a bit about other connections as well. Like we were deciding on, if we wanted to do WebSockets versus webhooks. And to be fair, I'm going to be honest, I'm not even going to include this because this was out of scope. We should have never looked at other services because we're trying to just solve the problem for Twitch, right? So I really do believe that We don't want that. We really want to solve it for Twitch. And so what are our goals? We then talk about our goals. We say that, we receive events from Twitch sub event individually, right? We want to be able to run a single process for each event. Instead of running more services in the cloud, we would prefer to run things that when needed and keep things running 24/7, only run required, right? We talk about running multiple tasks in sequence, event, trigger, right? So we want to say like an event happens in sequence on event, right? So a specific event happens. We want that to trigger potentially multiple things, right? And all of that. So like when a go live happens, for example, right? We want to receive the event to process for the channel, right? We then download the Twitch preview and store it in S3. Then we run the following in parallel to notify, right? And we generate a Discord notification and send, and then we generate a Twitter notification and send, right? So this is a bit of like what our goals are. And then we had some suggestions. Somebody brought up cloud events, which I don't know if this is basically the same thing. Oh, okay. I see. Let's move this down. So let's not worry about suggestions because we already had suggestions here as well. Oh no, this was for that. Okay, I see. Sorry, let me actually figure out what I want to do with this. Oh wait, yeah, no, this isn't AWS cloud events. This is the cloud events specification, right? And so this is just a side thing. Don't worry about this. Then we also talked a bit about serverless databases. Now, serverless databases is a bit out of scope here, but the main TLDR is that we also wanted to try and figure out if there's a way to store this data without having to pay for CPU time for our database, right? These two I'm not gonna, or these parts I'm not gonna include in the technical document. However, here's what I am gonna do. I really want to start putting things back into the wiki. If you guys don't remember, we have the Alta 4 wiki. As a matter of fact, I do want to reimagine the wiki, right? Like right now, the wiki is nice. It's a nice Discord thing. You can log in and sign up. I'm going to put this in the technical documents section of the wiki. Give it a second because a bunch of people probably just went to it. So if you go to technical design documents section of it, there's actually a bunch of documents in here that already existed from previous streams. This is one of the reasons why I want to redo the wiki is Discourse has not been good to us. So if you go to the wiki, if you take a look at that, this is where all of like other documents we've been doing exist, like Discord managed roles. I actually did a very similar thing where we sat down and we broke down like Discord managed roles. We wrote our problem out, all that kind of stuff. I'm going to keep doing this. Here's the reason why. I really like the wiki. And I think as we keep building software and stuff like that, it's going to be more crucial for us to share this information because I think you guys are really interested in it. You know what I mean? It does have performance issues. However, here's what I'm going to do. I'm going to post a technical design document once I get a brief minute because I also want to include the flowchart that we created, right? And so with everything that we just talked about, right now you should be able to see and understand this a lot better where the Twitch API goes out to our ingress, right? That ingress is what handles all of our HTTP traffic. And that ingress forwards it to the backend API that handles the Twitch sub events, right? That will then forward it to EventBridge, as we said, our event bus to fire and handle all of our Lambdas, right? We also have the path of creating the subscriptions where a user, when they go into the ingress to set up a Twitch account, right? We want the dashboard BFF to also go out to EventBridge and tell it, hey, an event just happened, do all of these things. And then the final thing is that we also want our crons, right? So, there's a lot of really good stuff here that I want to show you guys. As a matter of fact, there's also like some other things in here too that we talked about. Again, serverless DB. We didn't really talk about this at all, but one of the things that I also want to fix is right now, if you go to the announcements channel in our Discord, which by the way, check out the Discord. Thank you. I appreciate that. And if you click on this link and you open it in the browser, this actually takes you to an API URL, API Quirk Tools. That's because this URL is proxied through the API to return a message or an image from the bucket. I did not think that this could have very well just been a CDN. And so the first implementation I did it as a proxy through the API service. However, in the next version, when we download that Twitch preview, this Lambda function, right? this Lambda function is going to put it in a bucket that's going to go into a CloudFront distribution. And this distribution will be sitting behind the CDN of CloudFront. So we don't have to worry anymore about like also having this up so that we can receive preview images. So that's another change that I really wanted to make to try and improve the whole, the whole implementation. So that's another thing that's also in this that we didn't really talk about at all, which is how does the user get their, or how does how does Discord or whatever get their messages? That's basically how they're going to get it through the CDN. Isn't that the same flow, or isn't it the same flow that Cadence or Temporal do? What is? So yeah, be sure to check out the wiki and all that good stuff. All right, guys, I do have to call it here, though. Thank you guys so much for hanging out with me today. Like I said, do check out the wiki. Another thing I will say, and this is what I, kind of just, here, let me just start this. If you're new to the channel, hi, my name is BG. I'm one of the co-hosts of the Alta 4 stream. Thank you so much for being with me today. I hope you guys enjoyed yourself. I am beyond excited to rewrite Quirk. I genuinely think we can make a pretty awesome platform, and I genuinely think that we can make a platform that could rival Stream Elements, Streamlabs. Like, I really do think there's potential for us to make something really great out there. So I'm excited, and I'm really excited to build it like this in a really smart, thought out ways that help us scale, and also scale on a budget, because we got a ball on a budget, baby. All right. So if you are new to the channel, thank you guys so much for hanging out with me today. If you like this stream and you want to see more streams like this, guess what? I stream multiple times throughout the week, normally Mondays, Wednesdays, and Fridays. However, sometimes I do stream on off days like Tuesdays and Thursdays. It really just depends, but I normally try and stream 2 to 3 times a week, and I normally start anywhere between 8 a.m. and 10 a.m. Pacific Standard Time. I also have a wonderful co-host by the name of Atoda, who is learning how to program for the very first time. He is just getting his feetsies wet in the programming world. And so if you guys are interested in hanging out with him, he streams on the weekends, on Saturdays and Sundays, and he's also going to be doing night streams here coming up soon. So if you guys are interested in more advanced content and stuff like that, you're welcome to hang out with me. If you're also interested in seeing a newer approach to programming, how to get started with it and all that kind of stuff, be sure to hang out with Atoda, whether it be on nights or on the weekends. Thank you guys again so much for hanging out with me today. Again, if you are interested in any of our notifications, also be aware, chat, that we in our Discord have a roles section, a server roles section. If you want to get an Alta 4 Wiki message to know when I post out new stuff, you'll be able to get that by just subscribing here. You click this little button and bam, you get subscribed to that role. So be sure to subscribe to any of the roles for any of the updates, whether it be Alta 4 Wiki, LSP Containers, Quirk, TwitchCon, which, will be coming around the corner pretty soon. Or Twitter or anything else. So yeah, be sure to check out the Discord. The Discord is also a fantastic place filled with wonderful people. Outside of that, be sure to check out our YouTube. As I said, I know I promised a YouTube video this week. I am sorry. I swear to you, I am working on it. Work has been, unfortunately, very busy. I am trying to take on a bit more ownership at the company and trying to get into a new principal position. And because of that, it's taking a little bit more of my time, but I'm really excited about it. I want to become a principal engineer. I think what we did today is a good example of the kind of stuff I really love doing. And this is really a lot of what principal engineers do. We sit down and we think about, or, they sit down and they think about, like, how are we going to build this and how are we going to build this well? So yeah, I hope you guys enjoyed it. And again, remember, check out the YouTube. Be sure to subscribe to both. The next video, again, I'm targeting for next week. It was supposed to come out this week, so we're close. We're very close. It will be coming out. But be sure to subscribe to both. And then remember, we also have the social media. Be sure to follow us on the Twitters for all of that other good stuff and whatnot as well. All right, let's go find somebody to the raid. Thank you guys again so much. I really appreciate you. You guys have been fantastic. Let's go say hi to somebody, and yeah. Let's see here. So we just raided Acorn recently. Oh, let's raid this guy. I think he's live right now. Let's see here. Actually, hold on. A lot of people are offline already. I'm glad you guys enjoyed it. Seriously, I'm glad you guys enjoyed it. All right, let's go raid somebody that we haven't raided in a while. I actually haven't seen him in a while. Now, he does do DevOps streams, which is why we're going to go say hi to him. But it looks like he might be doing some .NET stuff right now or something like it. So let's go say hi to J.W. Again, he does do DevOps streams, so you can at least ask him about DevOps and things he's interested in. But regardless, let's go give him a kind hello, and if anything, yeah, make fun of him for using .NET. All right, have a good one, guys. Appreciate you. Love you. Enjoy yourselves. I will see you Friday. Yeah, Friday for more Alta 4 streams. Oh, wait. Sorry. Hold on. Let me say it this way. This is how I want to say our goodbyes going forward. Hold on. Okay. Hi. Thank you for hanging out with me today. I appreciate it. Thank you. I hope you enjoyed the raid with J.W. And have a great rest of your evening. I will see you tomorrow or Friday for more Alta 4 streams. All right. See you guys. Bye.